I was recently reading an article from Discord where they're storing 120 million messages a day with only 4 backend engineers. What's more is that was in 2017. Now in 2021, that number is probably a billion, if not tens of billions of messages a day with a really minimal staff. So the question is, how do they do this? And the answer is a NoSQL database, an open source NoSQL database called Cassandra. In this one, I'm going to show you how to integrate the Python web framework called FastAPI with the managed database service for Cassandra called Astra DB. Now that's provided by DataStax, and they actually sponsored this video, but the idea here is we want to see something practical. Now I could tell you all about the project itself, but let's actually take a look at why I think this is worth your time by seeing actual code and how quickly it can adapt to the changes that we might need. I want to show you a quick demo. First off, this is one of the responses, and this is data that's stored in Astra DB. It actually brings back this data, and we can look it up at any time. Now, it's not really that much data at this point, but the cool thing is we can actually look at it, and we can see all of the scraping events that have occurred. Now, we're going to actually do this one time with a pre-existing data item, and then we're going to go ahead and add a new one. So jumping into our Jupyter notebook here, I'm just going to run this example real fast with this data. So what we will do is actually implement our own scraping client, as well as methods to scrape a data set from, well, in our case, Amazon.com, which I'll show you where we're scraping that data in just a moment. So it will take a moment to do this because we implemented a endless scroll feature. So it'll continuously scroll till, well, the page won't scroll anymore. And so the idea here too is to grab all of the data we possibly can and put it into a dictionary. This is a lot of data. And actually, the thing that I'm excited about, I'm going to show you in just a moment. But one of the things with this is after I have all this data, I want to validate it using Pydantic to get only the data I'm interested in for my AstraDB Cassandra database models. So then we actually add it in and store it like that. So if I refresh in here, notice that it's all stored. I've got another event. And that is pretty simple, but this is the thing that I'm really excited about. We look at this data set. So this is the raw data from Amazon.com. It has a bunch of things that maybe I want to keep, or maybe I want to store at some point. Let's say, for instance, this brand name right here. If we look at our current data, I don't have the brand name anywhere. So I want to go ahead and add it. So that means I'm going to jump into my Cassandra models here. So let's say, for instance, this model right here. Instead of title, I'm going to go ahead and add a new one for brand. And I'm also going to put this into my scrape event here, also brand. And when it's empty like this, I don't have to add a value. I also want to make sure that my schema, the actual schema that I end up using for this, will also have this data. And of course, we'll go over this once you get in there. But the idea is we scrape the data, the raw data, into a dataset dictionary like we just saw. So that's right here. Then we need to validate that data, ensure that it's the correct data we want, and then we'll go ahead and add it into our database. So let me give this a shot. I'm going to restart this kernel, restart and clear output. And again, this is existing product that I've already scraped, right? So let's go ahead and run this. And it will take a moment. So I'm going to pause the video. And it finished. Here's our data set. We scroll down a bit. Here's our validated data. Now with this new brand here, and here's it is in the database. I refresh this endpoint on my FastAPI. Again, this is coming directly from AstraDB. This is it, right? There's the brand here. And in some of these scrape events, I actually don't display the brand. I certainly can, and that is also sort of easy to do. We just go back into the schema here, and we just add it where appropriate. I think it's going to be right here. And so we now have this schema. We refresh in here, and this will give us the brand when the brand is in there. So of course, this is when I actually added the brand. All of my old values in here do not show up. Now, if you're coming from like Django or a SQL database in FastAPI, I just did something that should be mind-blowing. I added a new field and didn't touch a whole lot. Now I'll show you the actual code that ends up happening here. And if we go into main.py, where I have my FastAPI application, I've got this stuff right here, where it's syncing the table. So when FastAPI starts, it's going to sync all of the database tables coming from these models, right? It's really that simple. And when I actually added it in here, FastAPI knew to restart the application itself, right? It didn't happen inside of the Jupyter notebook at all. It was all FastAPI. So if FastAPI wasn't running, then I would have had to run these items in here inside of the actual Jupyter notebook. I would have had to sync this table after this session, much like we see in this session right here. That to me is just like so cool. It's so easy. It's also incredibly fast, right? So it's like not something that I need to wait for, both in terms of the speed of just writing this data and retrieving it, but also just adding the new column. It's no big deal. So let's go ahead and grab a new product, a product that I definitely do not have in here. So products, and there's not a whole lot in here, right? And a lot of them are test products. There's not a whole lot real products in here. So let's go into Amazon and let's just find one. So today deals, and I want to find one that has a actually physical product. So here's one. This might be one worth monitoring because it's a deal for today. So maybe the price goes down or maybe it goes back up. But the key for this is I actually want to find hardware. I'm going to scroll down here and I want to look for this right here. So this is the data that I'm looking to extract. Here is the ASIN. I'm going to go ahead and go back into my demo here, replace the ASIN here, and then we're going to run it. I'm going to go ahead and do kernel, restart, and run all, and then I'll pause the video and come back when it's done. All right, so it finished, and in this case, it does not have a price. The price is not actually showing up in the way that I have this formulated. Now, that's something you'll learn about when you actually learn how to do all the scraping, but all of this other data is in here, right? So we've got all this kinds of data, including the validated data and the event that was scraped. So now if I go into my FastAPI application and just type that ASIN in, I'll see all of that data as well. So if I were to run it again, it would also add into what's in here, right? It's going to definitely add that data. Now, it's not grabbing the price string because of how I have it set up, but it is grabbing all of this data and the things that I might want, right? So another aspect might be country of origin. Perhaps I want to add that in. Let's just verify in my data set that I'm even getting that. So in my data set, if I scroll down a bit, I want to see that there's a country of origin in here. And there it is. I did turn it into a slug version of the field name itself, which I'm just going to do a quick on-the-fly change because Python doesn't love slugs for field names. So let's go ahead and jump into our scraper here. And we want to look for the slugify method for our data set here. So here it is. And so all I'm going to do is say key equals to the original key dot replace and dash and then underscore. Okay, quick easy change, restart and run the kernel. And after a few seconds it finished. And now we have the actual country of origin being a little bit closer to what I want. So now into my models, yet again, I'm going to go ahead and add it into both the scrape event field and the product field. And again, just text. We could add a default in here or just leave it in as text. This is a default for all future values. So we can go ahead and save that. And then again, in our schema here, the country of origin, an optional string, both in terms of the scrape event and the list schema in this case. So I'm going to go ahead and save that. And our FastAPI application should have actually updated. It looks like it didn't, so I'm going to go ahead and run that. It looked like it had a little bit of an error for this union class. And I see why. This should not be equals. This should be a colon, just like that. Let's just change those two. Okay, no big deal. And so now the tables should be synced. I didn't do anything else other than save everything and change the fields in here, right? And so now going back into my demo notebook here, I'm going to restart and run again. And while that's running, I can absolutely go into the product itself. And now I see that the country of origin is missing in this particular model. This is the main product model, right? These are all scrape events. If I refresh in here, once the demo is done, I will absolutely see the country of origin updated. Now, while that's happening, I also want to look at the CRUD model here. So I think what's cool about this is it, right? So if you come from the SQL world, you're probably not going to call a create every single time. With the Cassandra database and Astra DB, you can call create and it's going to update the primary key just like that. Look at that. And then we have this new country of origin. And of course, I can run this as many times as I want, or I can try and find another product, right? What is another product I might want to, track? Let's just say this camera right here, one of these cameras. I'm hoping that I'll get the price this time, but it's certainly possible that I might not, especially based off of, well, it's kind of hard to even diagnose where the price is right here. So I'm going to go ahead and try. Let's grab the ASIN from the URL this time, which is right next to this right there. And of course, you can always just search for that same number. And again, if the price does not come in, it's no big deal. You'll learn how to actually modify the scraper itself to find that price. I'll let this run. While it does, I'm going to go ahead and jump over here. Take a look at, I actually do not have that value found. I don't have a server handler for the lookup. It's not that big of a deal, but now it should be in there. What do you know? It actually did get the price, which is cool. We refresh in here and there we go. Now I have an event that's actually did scrape this. So again, I can restart and run all again, and I can do that as many times as I want. In fact, one of the other key parts of this is actually scheduling these things out, running periodic tasks. So that is definitely one of the things that we're going to do is run periodic tasks based off of the current products that I have. Those current products are going to be scraped using, well, a lot of the method that we have been using here, which is also really, really nice. Now, something I won't demo, but is really cool to have too, is we can add this data using an API endpoint as well, as in the actual scraped data set, the data that's coming through right here. This data set I could actually send into an endpoint and it will actually clean out the data that is necessary from that bigger data set item too. It's just so cool. I really, really like using all of these things, and I hope that you do too. Let's go ahead and jump in and get started. In this series, we are going to be using Python to perform web scraping. Now, if you don't know what that means, it just means that we're going to write some code to open up any web page and extract data that we're looking for specifically. And then we're also going to do this on a schedule, which means our data is going to start to get really big. So that means we're going to actually use a Cassandra NoSQL database to handle this because it can manage massive amounts of data. If you're web scraping on a schedule, let's say every 10 seconds, you're going to start to get a lot of data really, really quickly. And the Cassandra NoSQL database can absolutely handle it. Now, instead of actually starting to spin up our own database and actually manage that server, we're going to be using DataStax's Astra DB. Now, DataStax actually manages and runs the open source Cassandra project, which is really cool. This Astra DB is really just their managed service for that. And luckily for us, it gives us up to 80 gigabytes for free. That's amazing. So I'm going to show you how to implement all of these things. But before you do, go ahead and actually sign up for an account right here. They did sponsor this video, but the idea here is we need to learn how to practically implement all of these things. So to do this, we're going to be using a number of tools. Now, if you want to follow along with me, you can go to cfe.sh/github and look for the Scrape Websites with Python repository. And if you scroll down here, you'll see all of the tools we're going to be going through. Right, so this is a massive series that has a lot of really, really practical value. So hopefully you'll get into it. Now, before you do, I do recommend that you have some experience with Python. So 30 days of Python is my recommendation for that, and at least up to, day 15, maybe even day 12. But the idea is, do you know how to do classes? Do you know how to write functions? Do you know what strings are? If you do, you are good to go. You are good to start with this one. I'm also going to be using Visual Studio Code, so download that as your code editor, your text editor. You can use other ones if you're really comfortable with another one. And then the next thing, of course, is using Python 3.9. You want to use at least 3.6, but 3.9 is what I'll be using. So let's go ahead and actually set up our environment. I will say all of the links for everything are in the description below, and feel free to jump around to any section because depending on where you are, it is a good idea to jump around. Now we're going to go ahead and set up our project into VS Code. So be sure to go to the repo, which is linked, of course, in the description, and open up VS Code, create a folder you want to store this. Now I put it into my own users dev folder, and we can call it whatever you want. So like FastAPI, NoSQL scrape, something like that. And then in here, we're going to open that up, and I'm going to run the command of git clone that repo link and period. Now this is going to clone the latest version of this code, but this whole series is broken up into chunks, right? Each section has its own branch, which means we are in the third video right now. I'm going to go ahead and do git checkout 3-start, and that's going to give me whatever that is, which includes requirements.txt. So we're going to do that going forward. Now in the future, you will also be able to do 3-end or whatever section you're on. So if it's 10-in, you'll see the code at the end of that video. Now I actually already have this project on my system here, and so I'm going to be using it in this folder. So now what we want to do is actually create our virtual environment with the Python 3 version that we have installed, which in my case is 3.9.7. The key is just Python 3.9. And so we're going to go ahead and do Python 3-m venv period. This, of course, is going to create our virtual environment. And now, in my case, I'm actually going to update my gitignore file to ignore, bin, include, and lib, just to make sure that that's in there. And then I'm on a Mac, so I'm going to go ahead and do .ds store. That's another thing I want to ignore from our Git repo. Okay, and then let's go ahead and activate our virtual environment with source bin/activate on Mac and Linux. If you're on Windows, it's simply just script/activate, just like that. Okay, so the reason we're using a virtual environment is really to separate the version problems that can arise when you are creating Python projects, right? You just want to keep that version local to your local project, thus you use a virtual environment. But by all means, if you're using pipenv, go ahead and use that. If you're using Poetry, if you're using Anaconda, a lot of these things can work, but using the built-in virtual environment is what I recommend at this point. So now I'm going to just run pip install -r requirements.txt. And so that should install everything that we'll need, which of course that list is all right here. Now, one of the things that might come up as a problem for you is specifically Selenium. So in this setup folder we have here, there's a number of things on getting your system set up. Now, I'm actually not going to go through this because every system is so much different. Like in my case with macOS, I would just use brew and install Chrome driver. We need Chrome driver to work with our actual system here in Selenium. The other thing is actually Redis as well. This whole guide here will get you through that. Now, if you're not familiar with a markdown file, by all means, go into this guide on our repo. The repo will have the most up-to-date code. So of course you just pulled from the repo, you just cloned from the repo. So there's a good chance that you had that. And of course, hopefully at this point, you may have already asked, hey, I don't have Git installed. Make sure you install Git. There are so many tools that you need to get to the point where making all this is incredibly useful for you. But anyway, so at this point, I'm going to assume that you have all the requirements done and you have all the setup that you need. Of course, we will come back to the setup if we need to in the future. And worst case scenario with something like Redis, you could always install it on a virtual machine. So you Windows users will have a little bit harder time getting Redis going. It's not that hard, but it is something that is not always that fun in setting up. So if you do have questions, let us know in the comments. Otherwise, let's keep going. Now we're going to start the process of integrating Python with Cassandra using the Astra DB service. So definitely go to this link right here and sign up on DataStax for your free account. Now, of course, it's 80 gigabytes a month free. That's really, really good. And so now we're going to go ahead and jump into the console, assuming that you did sign up for those things. And we're going to go ahead and create our first database. In this case, I'll just call it a FastAPI DB. and I'll give it a key space name of scraper app. Now you could always add another key space like scraper app test. I'm just going to leave it in very simple and use scraper app. Now the key space itself will have the tables in it, right? It's not going to be in the database per se. It's going to be in the key space, which is in the database, of course. So you can have many different key spaces in one single database. So if you ever needed to add more key spaces, you can. And of course, if you need to change your database, well, you can't. You have to just create a brand new one, which is also incredibly easy. So anyways, we've got our key space name, and we can always add more later. Just keep that in mind. Next, we need to choose a provider and region. Now this, in my opinion, just pick one that's close to you physically, or the service that you like and the one that's close to you. So if you're using Google Cloud, for example, you just want to get one that's close. In my case, I'm in Texas, so one of these east ones works just fine. Now, if you're going to be using this on a web application, like we will eventually, and you bring that web application into production, you're probably going to want to have the web application close to whatever region you end up using, which all of that should be close to your users probably. Now, there's a lot of caveats to what I just said, but just keep in mind that you can always change this later or add a new one later. We're just learning right now. So let's go ahead and create this database. Now this won't take that long, but it does have to provision, of course. So in my case, it is currently provisioning. So while it's doing that, I'm going to go ahead and add a new token to my application. So jumping back into my application, I'm going to create a file called .env. So this is for managing our environment variables. And if you're familiar with Git, this is not going to be tracked by default. So in my git ignore, I should have a .env file already in here, as I do. So that's what I want to add these credentials to. I definitely do not want to share them because they'll have access to my entire data stacks, AstraDB configuration and my organization. It's all admin stuff. So let's go into our current organization here, right? Click on organization settings, go down to token management, select role, go to admin user, generate token. Okay. So these tokens we want to keep in those environment variables. Now you can easily just delete them later, right? You just come in here and hit delete. So if you have to, just go ahead and do that. It's not that big of a deal. So we'll go ahead and copy the client ID here. So this is going to be our first one, and we're going to save it in the environment variables as AstraDB client ID. And we'll paste that in here. No string is necessary. And then AstraDB and client secret. We'll go ahead and grab that client secret. The token itself we won't really need to use, but we might as well just bring it in here as well. So AstraDB client or app token, I think it called it, app token. Okay, cool. So this is really just combining the client ID and the client part of the client secret, but definitely the client ID is in here as well. Okay, cool. So now that we've got that, let's go ahead and check to see if our bundle has been created, or in the other words, our actual FastAPI database, has that been created? Looks like it has. Status is active. So now what we want to do is connect it. So what we're trying to do here is downloading the driver. So we're going to be using cassandra-driver. So we need to go to Python to download this bundle. Now, just to verify that we already have cassandra-driver in here, it was in our requirements.txt. So if you didn't install it, be sure to install it. Now, I'm actually not going to be using it just yet. We'll do that in the next part. But the idea here is just to at least configure environment variables as well as the location for this bundle. So I'm going to go ahead and download this bundle now. And it's going to be named based off of your database name, right? So secure connect FastAPI db.zip. Now I actually want to bring this into my project. So this bundle we do not want in Git at all. We don't want to share this bundle in its current state. I'll show you how to do it later, but for now I'm not going to do that. So I'm going to go ahead and create my folder called app. Inside of here, I'm going to go ahead and create another folder called ignored. The reason for that is to go into our git ignore file here and simply do app ignored. Okay. We will change this later, but that's what I want to leave it in for now. With that, I'm going to bring in my bundle over. Okay. So in my case, I'm just going to rename this as just simply connect.zip. You do not need to unzip it. You can just leave it just like that. Okay, so this is the baseline of what we need. Next, we're actually going to configure our Cassandra driver. All right, so now we're going to go ahead and actually configure the Cassandra driver. So back into our database, into Connect, and under Python, you can actually see all of the steps to configure this driver in some way. But the key thing is we're actually going to be doing this step right here. So let's go ahead and copy that, and we'll bring it into our app folder here, and I'll just call it db.py, and we'll paste this in. So I think this is fairly obvious on how we're going to go ahead and solve this. Now, the first one is the actual bundle itself. That was our connect.zip. I need the actual path for this. And of course, the reason I'm setting it up in this way is so that I can actually turn this into a FastAPI app later. And that's kind of the key here. And so what I want to do is I'm actually going to turn these into two different commands. First off is going to be the git cluster command. And that's going to be like this. So I'll go ahead and put these in here. And that's going to return the cluster. And then we'll define get session in here. And of course, it's going to use get cluster. And this is going to return this session. Okay, so there might be more things that we'll have to add in here, but for now, these are the methods that I want to use. So let's actually go ahead and implement this in some form, and that way we can see a bunch of stuff. I'm also going to go ahead and add in this row call here, like it did, and I'll just call session equals to get session. This is just to verify that everything is configured correctly. So of course, if I do it now and I run Python app and db.py, hit enter, what I'll get is probably an error, but it will hang for a little while because, well, it's trying to configure somehow. And yeah, it didn't work. Okay, so notice that it is connect.zip. We never had to unzip that folder. So I can actually put it in as a string like ignored /connect.zip. This should actually work now if I spell it correctly. But unfortunately, this is not great, right? I don't actually like putting paths in this way. I would rather use pathlib for it. So we'll go ahead and do that. We're going to import pathlib. And the first thing is, I'll say base directory. This is going to be the app directory itself, which is pathlib.path of this file and whatever that parent folder is. So that file is, db.py, parent folder is right there. And then I'm going to go ahead and do my, let's say my cluster bundle. And this is going to be, of course, the base directory /ignored and then /connect.zip, but ignored as a string, and then turn this whole thing into a string. Okay, maybe at some point it will use pathlib, but right now it uses an absolute path to that string. That's the best way to do it. So we save that, we run again. This time it shouldn't say not found. It should actually find it, but then it has token errors. Okay, so how do we actually get the client secret and client ID? Now, if you don't follow best practices, you could just copy and paste these things in here. But we do follow best practices, so we're going to go ahead and import OS. And then we're also going to import .env. So that package that I'll mention from .env, import load.env. This is going to load up our environment variables. So go ahead and just call it like that. And that is coming from the python.env right here. And then of course, Cassandra driver is the other portion of that. And so with that, I can actually call what's in my .env file. So if I copied this whole thing, came in here, pasted it in, and just went this equals to os.environ.get, that key there, then the next key, like that. Notice I do not need the app token. It's just looking for the client ID and client secret, which I have. And so now I should be able to go here and here. Okay, so we save that and we'll run it again. This time, we shouldn't see major errors. And if we don't see major errors, then we've configured correctly. What do you know? There it is. Cool. So it's giving us our version and it is fully connected. Now, there are things that I will want to implement later when I actually bring this into FastAPI, but for now, this is good. This is all I'll really need to actually start modeling our data. Now that we can actually connect to a session, it's time to actually start storing data in our Cassandra database. So inside of our app here, we're going to go ahead and do models.py. Now, models.py is going to hold all of the classes that we want to turn into both tables and columns within that table. Before we get there, let's actually think about what it is that I'm trying to do. So I'm going to go ahead and say data is equal to something that I want to actually store. So in the case of Amazon, what we're going to be scraping, we'll have an ASN, which is really the Amazon, ID number. And then we are also going to have maybe a product title. So let's go ahead and say title, and we'll go ahead and say mark 1. Okay, so this is the data I want to store. Granted, in Python right now, it's just a dictionary. And if I had a million of these, well, it wouldn't be efficient in Python, but it would certainly be efficient in Cassandra. So what we want to do is turn this into a class. Now, the intuition there would be, okay, well, let's take this class and we'll call it a product. And then we'll go ahead and do ASN. And I noticed that this is a string, so I'll just give it a data type of string, and then a title, and I'll give that a data type of string as well. So of course, this is a Python data class. It's getting closer to being a Python data class. Now, in this case, I actually want to say maybe the title is equal to none. The default value is just simply none. But the actual Amazon number, that ID number, is something that we want to use to look up this particular product later. So in other words, let's actually jump into Amazon.com right now. And let's go ahead and go to any product. It doesn't really matter what product you end up using. Let's look at this right here. I don't know what it is. It's a generator. Okay. So we're in this product, and what we see at the very top is this number right here, right? Every single Amazon site has that number. And actually, if you scroll down a bit, what you will eventually see is some data about this product. This is true on all products, although the way it's laid out might be a little bit different. And you see this ASIN, right? There it is right there. Okay, so that is the number that is for sure the unique identifier for this product. You can definitely do all this research on it, but that's the idea here. This is the unique identifier. So this one right here is how we're going to look up this product in our database. Now we're going to do all of that in a little bit, but this is the key one. This is the primary key. Yeah, you see what I did there if you're coming from SQL especially. Okay, so the idea here is we want to declare this as primary key, right? So how do we actually go about doing that? The title itself is not a primary key. We're not going to be doing lookups based off of the title, especially with a string, right? So doing lookups off of a string aren't nearly as efficient as doing it based off of either an index value or a primary key in this case. Again, we'll go through these things as we go a little bit further. So for now, let's go ahead and actually implement this by creating our first model. So we'll go ahead and do from cassandra.sql engine, or CQL engine rather, import columns. And then we're going to go ahead and do from cassandra.sql engine.models import model. Okay, so declare this to turn this into a Cassandra model. We'll go ahead and do that. This actually turns it into a table, and the tables actually exist in key spaces. So what is our key space? Okay, this is a big question. Now, when we actually connect to our cluster, that's going to connect to our database for us, right? So that's coming from that secure connect bundle is doing that for us. But what it's not doing is the key space itself. So we actually have to get that key space, and that of course is inside of our project here. And if you scroll to the bottom, you've got your key spaces here. You could always add a new one if you just want to test it out, but here we go. So there's our key space, okay? So now these two are going to be columns in our table. So the first one, the Amazon shipping identification number, I think it's called, is simply columns.text. And then in here, we have options to declare a primary key. And we can say required equals to true as well. So the same concept is true for our title, right? So in the case of our title, it is certainly not a primary key, and it may or may not be required. I'm just going to leave it as not required, and we'll see what happens in a little bit when we actually start using this. But this is a very basic model based off of this data right here. And I'm actually going to leave it just like this. One of the advantages of using Cassandra is later changing things. The things that we might not want to change or probably won't change are the primary key, the way we're going to end up looking this up. Now, what this is going to translate is to in product.objects.filter asyn equals to, some Amazon shipping number. And that is essentially one of the ways we're going to be looking things up. What you're not going to do is filter title equals to, mark 1. That is kind of the key here of these two things. Now, if we did turn this into an index, then you would be able to actually start filtering this way, but I don't actually recommend it. I actually recommend for speed to use an actual identification number. And we'll get back to that in a little bit later, but that's kind of the idea. So we'll go ahead and say not this, def this. Okay, so like definitely this. Okay, cool. So that's our baseline model. Let's actually start using this data now, or actually start storing data in this model. All right, so I want to start actually working with this product model, but before I do, I have to add a new item in my get session call here. And that is related to actually setting the default connection and registering this connection. This is so our actual model will work correctly. So I'm going to go ahead and import it in here. This is register connection and simply set the actual default connection as well. This is just a quick and easy way to ensure that that product model will work. So we register the connection with this session, give the string of the session, and then pass in the session argument itself. And then we'll go ahead and do our set default connection as well, and also that string of that session. Okay, so now that we've got that, I'm going to go ahead and open up crud.py. Let's go ahead and make that module here. And so the crud module, what it's going to allow me to do is actually run various commands that relate to creating, retrieving, updating, and deleting. Initially, we'll just do create so we can see how it works. So let's go ahead and import from .models. We're going to import our product. And then I'm also going to go from .db. We're going to import that session from .db import get session. And we're going to declare our session here. So get session. And then we're also going to use our product model. So to do that, we'll go ahead and say, let's define create entry. And it's going to take in a data class that, or a data argument as a dictionary. And we're just going to do product.create, and then we'll unpack that data, right? That's it. And actually I'll return whatever that value is, which will be an instance of this. Okay, so let's go ahead and save it. Let's run it into Python, and then I'll do from app.crud. We're going to import the create entry method here. And it will take a moment because it's going to boot up that session. Now, in this case, I get a 0, a key error of 0. And that's because when in my database right here, it's trying to execute that get session call right there. So let's go ahead and save that and get rid of that comment, and then just try this again by importing it. We should be able to actually run it now. There we go. Okay, and so the data I want is very similar to what we had here, right? So we'll go ahead and say data equals to, well, we might as well just copy and paste this. Okay, so there's our data. And now I'm going to go ahead and try and create it with just simply like that. There we go. We've got table scraper app dot product does not exist. Okay, cool. So there's a reason for this, and we'll get to it. But what it showed us is that this product model, the default table name is simply just product, just a lowercase of this, which we'll see throughout. So in order for us to actually use that table, we have to call something called sync table. So we're going to go ahead and do from cassandra.cql engine .management. We're going to import sync table. And in here, I'll go ahead and sync the table for the product itself. Okay, so yet again, we'll exit out, come into Python, And we can press up a couple times to actually grab that import. Oops, this should be CQL, not CSQL. Let's try that again. And there we go. So it should now import it. And we have this warning right here that we can work with or change. We just go ahead and put it into our environment variables. And I'll just go ahead and set it equal to 0, I believe. So let's go ahead and try that again. But seeing that warning actually is a good sign. It's hopefully showing me that everything's working. This is just related to the package itself. And now it's in the environment variable. It's gone. Okay, cool. So going back into this, we should not have any issues now creating an entry. So let's go ahead and copy that data again. And let's call create entry on that data. There it is. And you know what? Let's do it again. And again, and again, and again. Now, if you're coming from the world of SQL, you might have already seen this before, and you would sort of expect some, well, this result. So if I did product.objects.all, hit enter. This is a query set, but I actually didn't import the product. So let's go ahead and import the product and try that again. This is giving you a model query set, which is really nice. This is something we can iterate through, and we could also just say list around it. What? It only has one. That's odd, but I called it like several times. What if I just change this a little bit and put that in? And now call that data command again. Okay, so it's a little bit different on the asyn. List it out. Hey, now it has 2. What if I change the numbers here? Again. And call it again. Okay, looks like the title changed. List things out. There's still only 2. How cool is that? Okay, so this is maybe expected behavior or unexpected behavior, depending on your background. In my opinion, this is great. This means that I can actually update an entry with that create call. I mean, that's exactly what's happening because it's going off of the primary key, which is this, and any change that you made to it. Now, in my case, it's changing the title, so it's actually updating this. And when I called this create function multiple times, I'm actually using the exact same primary key every time. So when I use the same primary key, it will update other fields in here. Now, this isn't always perfectly accurate for every possible thing, but the idea here is this is how I would store the product itself, right? So any sort of detail about the product, this is what I'm storing. This is not going to be a regular occurrence, right? So what we want to look at is this same concept, but storing multiple iterations, the same asyn, right? But then a price lookup, an actual lookup event. So let's go ahead and do that. Let's go ahead and implement one of my favorite things about using Cassandra. We look at this model right here and we're like, hey, I actually want a new column in here. So I'm going to go ahead and do price string equals to columns, and we'll go ahead and say .text. There you go. You now have a new column, and CRUD will work as it was, which I think is pretty cool. Now, of course, if we wanted to add some attributes to that column, we could go into the documentation for CQL engine and look for maybe a default, right? So we can actually pass in a default here, either a value or a callable. So let's say the default is equal to the string of -1. Okay, so now let's go ahead and try this out. I'm going to go ahead and go into Python, go from app. We're going to import CRUD and models. This should take a minute, but what it will allow me to do is something like this, where it's product equals to models.product. You don't have to do it that way, but I'll go ahead and list out product.objects.all. Hit enter. What do you know? Price string is in there. It is listed as none, right? Okay, so that's important. Now let's go ahead and actually use CRUD again with some new data. Okay, Actually, I'm going to change the ID here as in testing 123. That's important. And then we'll do crud.createData. I believe that's what we called it. Create entry. And use that data. Hit enter. And now it has a default value, right? So the default doesn't apply to all of the old ones. There's ways to do that, to actually apply to the old ones, add a default to them, or update them, in other words. But the default will actually apply to all of the future ones. Now, what if I actually change the default to like -100, right? And let's just exit out of here and try that again. This time it's going to be that. And I'll have to, bring some of these things in. So let's, from app, import crud and models. Go ahead and do data and crud.create entry of that data. Hit enter. There we go. Our new default. Really, really nice. Now, part of the reason that we can do this, just adding a column willy-nilly, is because of how Cassandra works, but also because we're using this sync table right here. So I don't have to run migrations. I don't have to make a bunch of changes to the actual table itself. I can just change them on the fly like this. Now, it's not true for every column, but for columns like this, where I'm just adding additional context, I can totally do it. It's pretty sweet, don't you think? Now we actually want to track an actual scrape event. So very similar to this create entry, we are going to want to have something like create scrape entry, where it's essentially adding new items to our database. Because if you think about it, the current product itself, this current model, is going to be updating based off of this asyn. So if the asyn exists in the database, it's just going to update all the other fields. If it does not exist, then it's just going to add it in. That's not what we want. We just want to always add it in as the default. So that's what this actual CRUD function is going to do. So to do that, we actually need to create another table. This table itself is going to be defined a little bit differently. So we're going to call this the product scrape event. And now, instead of using our asyn here, we're going to pass in a different field, and that's going to be our UUID field. And it's going to be columns.UUID, just like that. And of course, this will now be our primary key here, just like this. So I could totally leave it like this, and it would actually work the same way as this one. As long as I had that UUID, I would be able to actually update that data. Exactly the same. But the UUID is something you probably aren't going to keep track of. The asyn is a lot easier to keep track of, and we have a reference, the actual place we're scraping from, right? So there's an asyn already in there. The UUID is not going to be something that you'll know off the top of your head or really keep track of in this case. Now, the asyn then, we still want to be able to look it up. Actually, we want to look it up like this. So really, we want to be able to go ahead and do this same thing, actually doing the same lookup. Now, that's on purpose. So how do we actually go about doing that? And that is by adding in the index being true here. It's really just that simple. And so now that we've got that, we can just bring this into CRUD, and we can sync the table and change this scrape entry right here, which is pretty cool. Let's go ahead and give it a shot with this original data right here. So let's go ahead and do Python, and we're going to import a few things. So from app, import CRUD and models. First off, let's go ahead and define our product scrape event model here. And it's going to be models.productScrapeEvent. The data itself is models.data. So we'll go ahead and run the function of create scrape entry with simply crud.create scrape entry of that data and hit enter. Okay. So right now it's saying that there's something missing, right? So the UUID column, I actually never set it. This is probably not that surprising, but it's true because in here, I'm just passing in that default data. Okay. So when it comes to a UUID field, especially this, we actually need to set it right before we create this item. So we're going to go ahead and grab this UUID here, and I'll just say data UUID is equal to that UUID field, and we're going to go ahead and do UUID 1. So UUID1 includes a timestamp in it, which is why we want to use that. So it actually gives me some sort of ordering in here as well, which is nice. So anyways, we've got the ability to create this data now. Let's try that again. We're going to have to do all of the exact same imports. Give it a moment to load up. Scrape event, the data, and then finally, we will run the scrape. Okay. So if I keep doing this, what I should see is the actual UUIDs changing, which is pretty cool. The other thing is I can actually see this by iterating through it. So for obj in the product scrape event.objects.all, I can actually print out each one of these. So obj.uuid and maybe obj.ascend. Hit enter, and it's very different. All of these are different, right? It doesn't look like they're that much different, but at the very beginning, you'll see that they are. And then we've got all of this test ID stuff, right? So it's actually storing as if it was doing a scrape event itself. So in this case, what I'd actually want to do is add one more CRUD item here. And this time, I'm going to actually go ahead and say add scrape event. Okay. So this time, I'm going to go ahead and just call each one of these. So it's just as simple as the product being equal to create entry of this data, and then the scrape event equals to create scrape entry, or let's call this scrape object to not confuse it with the name of this method. And then again, passing in the data and then returning back the product and the scrape object. Okay, so we're going to go ahead and save this, and we'll come back in to our model here. Okay, and so now what I'm going to do is run this all over again. This time I'm going to go ahead and hard code the dictionary into this data here. So we'll do the crud.create scrape entry, and the data ascend being, testing 1, 2, 3, and then the title being hello world. Okay, there we go. And so we run this a few times. Okay, and so we should actually be getting different scrape events as well as different products themselves, right? And we only did scrape entry. So let's try that again with the add scrape event, not create scrape entry. We should be getting both things in our database, just like that. And there we go. Okay, so on one hand, the product scrape event is incrementing. The actual product itself, that original model, is not incrementing, but it will change if we need it to. So if I said hello worlder, it changes the product itself right there. And then the product scrape event does not change, right? But now if I actually have a price in here, like let's say for instance, 32, let's put a $sign in front of it, which is why I put price string in here. And we did something like that. We've got price in here, and we've got, it should actually be price string. We definitely need to validate this data a little bit better, but for now we see I can actually have all of these events coming in here. And if you notice, this is actually working really fast, considering the fact that this is not on my local computer. The actual session with Cassandra is not on my local computer, and yours would be going just as fast, if not faster. So that's actually pretty cool, I think. Now we can always obviously look at these product scrape events now by doing for obj in models.productscrapeevent.objects.all. We can actually print out the obj itself, and it's going to be a lot, right? I just went through a lot. Okay, cool. So that is running these different actual Cassandra entries. It's pretty straightforward on how we do it. Now, the reason for this has to do with a couple things. First off, this is going to be my detail view, or the actual list view will feed into my detail view here. This is for our actual web application. This will pretty much only be on the detail view for the ascend, right? Because we know that whenever we do a scrape event, our product is going to store the ascend, which is that primary key. That's the main thing we're always going to want. After we understand that part, then we can start actually having scraping events happen on that primary product, which I think is also pretty awesome. Okay, so this actually is a bit tedious to write it out in Python like this, right? I totally understand that. So in the next part, we're going to go ahead and implement a Jupyter notebook to do all of these same things in a way that I think is a lot more practical for our project in general. Now we're going to go ahead and start using Jupyter for managing a lot of our experiments with our code. Now, writing everything in the Python shell like we have been works, but a lot of times we forget what we wrote, or there's just things that are lost in that context. And then a lot of times we have to actually exit out of the shell and then rerun things. So we're going to go ahead and use Jupyter. Now, if you've never used Jupyter before, it's really easy to use and it's all based in Python. So I'll show you everything that's going on in there as well. So to start up, we'll go ahead and run Jupyter Notebook. Okay. So this is going to be really good for our models, the actual Cassandra models, but it's also going to be really good for when we go to scrape our web pages. So this should have opened up for you the localhost 8888. And if it didn't, just click on one of these links or copy and paste them, and it'll open up just like this. Now what we want to do is just create a new folder right here by saying new and folder. Granted, if you did this inside of VS Code, that would have been fine too. I'm just going to go ahead and rename this folder to notebooks NBS. And then inside of here, we're going to go ahead and create a new Python 3 notebook. Okay, so just simply new and IPython 3 or IPython kernel. And so inside of here, we're going to rename this to working with Cassandra models. Okay, so the goal here is working with what I've already created, which is inside of this app folder here. And so as it stands right now, this is fine. I can totally work from this, but the problem is where the actual notebooks are located. So it's not like I can just do from app, import CRUD and models. If I run that, it's going to say no module name app. That's because of where it's located. So I need to actually change the directory, and we can do that with cd and there. Now I've been running these cells really fast because I've used Jupyter all the time. To run a cell, you just do shift and enter, shift and enter. Once you do shift and enter, it'll run that cell much like you were pressing enter in Python. But in here, you can press enter a lot inside of any given cell and write out a bunch of things. So shift and enter is going to be your best friend. Okay, so in this case, what I want to do is I actually want to run that example again of adding a scrape event. So thinking back to that, we had our data in models.data, right? So that should give us that original data dictionary. And then from there, I can use CRUD dot, and this was add scrape event of that data and hit enter. So something that is now pretty obvious to me is I can actually look at that data again and run it again, and I see there's a UUID field in here. So this would have been uncovered in the shell as well, but as you hopefully notice, it's happening here and it's a lot easier. Now the reason it's happening is because of this right here. This actual scrape entry is adding a field in there for that data for UUID. So if I try to run this again, I get this error. So what I can do is I can actually pass in an argument, let's say for instance like fresh, right? So I'm going to just say fresh equals to true. And in here, I'll go ahead and say fresh equals to, or wait, not there, but rather down here, we'll go ahead and say fresh equals to false, okay? And then if it is fresh, then we're going to go ahead and do what's called a deep copy. So a deep copy is really a simple way to duplicate a dictionary itself. So we're going to go ahead and import from up here, import copy. And now in this condition here, we'll go ahead and say data equals to copy.deep copy of the original data, right? That way, it's not going to necessarily be changing my original data. Every once in a while, you might want to have this enforcement. You want to prevent the pre-existing already scraped event data from coming in every once in a while. Anyways, so let's go ahead and restart this kernel here. And the other nice thing about the actual Jupyter notebooks is it does autosave for you, but you can also save too with just Command S or Control S depending on your system. So let's go ahead and run this again. And what we will see is it's going to scrape event. Oops, I needed to save my CRUD file here. I don't know if I did. So let's go ahead and restart and run all again. And now it should actually run that scrape event with the data being fresh, meaning this next data dictionary does not have a UUID now. And so we can run this as many times as we want for all of that data. So the other cool thing about this is I can actually now go ahead and iterate through all of these. So for obj in, let's say models.product.objects.all, I can print out the obj.asyn, right? And one of those I can actually use. So the asyn equals to obj, or let's say none first, right? And just set it equal to one of these. We see that, okay? So now I can actually go ahead and say for object in models dot the product scrape event dot objects dot filter asyn equaling to that asyn. And we'll go ahead and say, like if asyn is not none. And then we can print out obj.asyn and maybe obj.UUID. There we go. And so right now, hey, it is none. Run it again. It's still doing it. That's odd. Or maybe this asyn doesn't actually have any objects. So let's go ahead and try that. Looking at scrape events for that asyn. Yeah, it doesn't have any. Okay, so let's actually get one that does, and that's going to be testing 1, 2, 3. And so I'll go ahead and just set that directly instead of iterating through like this. Just set it right here. This one should have a lot. And there we go. And we can continuously run these, right? So I can keep running a bunch of scrape events over and over and over again, and then taking a look at everything that's being stored. What do you know? And that's pretty cool. Now, something else you'll probably see that's fairly common is to declare this as a variable, something like Q or QS. I use QS most of the time, but oftentimes you'll see it in as Q. And then we can actually enumerate this, and then we can actually see the iteration in here for each item. So you can really get a count for how many things that have come through here, right? And of course, we can keep running it. It actually doesn't really matter at this point. We'll continue to get more scrape events while the product itself is not really going to change, which is pretty cool. So the other thing is you actually might want to see any given query itself written in CQL. So we can do this with printing out what that query is. So here it is right there, right? So this means that I can actually run this inside of CQL. So let's go ahead and do that. I'm going to import the database and have our session here. So make sure you do that. And then we can do session.execute of that string there, hit enter, and that will give us a result. So I can actually say for row in that execution, I can print out what that row is, and this gives me that data, right? So this, of course, is in the product model itself, which is really nice, right? So obviously CQL has a lot more things that I can end up doing than just something like this. But at the very least, we now see two ways on how we could actually go about using any given item, right? So the other thing with this is if I actually put it in as Q, that's not the only way to find out what the query is itself. So another thing, obviously, that I do all the time is by looking at the dir of anything. And what we can see in here is this underscore execute query. And then also should be an underscore select query, right? And then in here as well, there should be something for different columns and all sorts of really cool stuff. So let's go ahead and do our select query and just print out the q.select query. It's a bound method. So we're going to go ahead and run that bound method. And there's that same query. Just another way to grab it. Now, I did see timestamp in there as well. Okay, another bound method. We'll get the timestamp. In this case, it's missing the positional argument of timestamp. I'm not going to jump into that really. The main thing was really just looking at the underscore select query so you can see exactly what it is that you might need to run at any given time for your execution, right? Just like that. So I wonder if we could actually just say, for instance, my query is equal to that, or the CQL query. If I can just run like this, and let's turn this back into a string here. And there we go. So another way to actually go about doing that. And of course you can print that out as you see fit. Now, hopefully this highlights as to why I want to use Jupyter Notebooks. It's not just for working with Cassandra models, but just rapid iteration, rapid testing. So there are other methods that I want you to try on your own. So if you go into the documentation, which I will definitely link in here at the very top on the GitHub repo, if you go in there and scroll down quite a bit, you'll definitely see a bunch of methods that you can use for every single model, because you might want to have it a little bit more advanced or add additional features to it. But we're going to be sticking with pretty straightforward and simple things at this point. So now what I want to do is start to actually add additional validation to ever getting to the point where I'm going to be putting it into the database itself, right? So in other words, I have the ability to store things in this data, and there is somewhat of validation that's built into it, but I want to make one other step of validation so that when I actually start implementing the FastAPI application, then I'll have better, actually more robust FastAPI ready validation for a given view or endpoint. Now we're going to go ahead and implement Pydantic to make sure that the data that's going to be saved with our Cassandra models is the correct data. So let's go ahead and duplicate this. And now I'm going to just rename this to Cassandra and Pydantic. Okay, so let's go ahead and jump in here. And what we want to do first is just really work off of the base model from Pydantic. So I'm going to go ahead and leave some of the session stuff in here, as well as the imports. And then we're going to go ahead and just build off of our Pydantic model. Okay, so I'm going to go ahead and run from Pydantic. We're going to import our base model. Okay, so what I want is my product base model, and we'll give it a base model here. So we'll set this as a class. And this, of course, is going to be based off of this right here. So the ASIN is going to be a string. Next is going to be our title, and that is also going to be a string. And that's it. So here is the baseline model. We can actually come in here and use that data again. And I'll go ahead and say the product equals to that, or really the product object equals to that. And then we can actually take a look at this product object dictionary. Okay, so this is what we'll actually pass in to the Cassandra models. Now you might be wondering, well, what am I doing this for? And it has nothing to do with this data, because this data is all valid, at least for this particular model. Instead, what I want to do is pass in some other data. So like say, for instance, ABC123 is equal to nothing, right? So now it's quite a bit different of data, but notice what's coming through. It's no longer allowing for this ABC123. That's not there, unless of course I put it in here as ABC123 in str. Now it will come in. So it just cleans out this data and there's no errors to it. The other part of this is if I actually have an error with the data, then I get a validation error that's coming in here that gives me at least a little bit better of a value that's showing up. But to me, it's actually just getting rid of some of that data that's not necessary in this case. And it also allows me to change what I want to require on the fly based off of Pydantic instead of needing to necessarily change something in my Cassandra database. Now, the other reason to use Pydantic is because if you are actually converting an old project that is running in FastAPI to use a Cassandra database, which I recommend, you can. It's going to be really easy based off of what we're about to do, which what we're about to do is, well, basically the same thing that we've been seeing. And that is literally just passing in this scrape data here like this. And again, we can go ahead and say the product dict just like that, right? And so that should actually create this, but we're getting this invalid columns. So I need to make sure I'm running all three of those. There we go. And so we do that again, and now I don't have those invalid columns. So this is the basic model for the product itself. Now, I actually don't usually call this models. Instead, I usually call it a schema because it's not really storing my data model, right? So Pydantic might call it a base model. I call it a schema. So I'm going to go ahead and do that. Let's go ahead and jump back into our app here, and I'll just say schema equals to schema.py. I'm going to import Pydantic, and then I'm going to import this product schema here. And I also want to have that same thing with my product scrape event. I'm going to do class and product scrape event schema, base model. And again, it's this right here. And now we have a UUID that we need to add in here. And this is of a UUID class. So to do that, we just are going to come in here and do from UUID import UUID. Okay, so that gives us that class. Now, if you recall, this is an actual optional value. Both the titles, we had those as optional values. That's really easy to fix. We just go ahead and do from typing, we import optional, and then we just wrap this around whatever value we want to declare as optional, just like that. Okay. So now that we have this, we can actually use this schema data. So again, schema, we'll go ahead and restart this kernel here. And this time we're going to go ahead and do schema dot the product scrape schema. And we'll go ahead and use, oops, we actually called this base model. We'll leave that in just like that for our testing purposes. But we've got our schema here, and I'll pass in this data, right? Or actually unpack this data. Oops, there we go. And so what we should have here is a field missing for the UUID field. So to better format this, we can actually just do try using that schema and then handle the exception, which is a Pydantic validation error. So from Pydantic, import validation error, and we'll go accept as E, and then we can print out e.json, and that gives me a little bit better of what's going on here, right? So the UUID is missing. So how would I actually go about creating the UUID data for this one? Well, it's exactly what we've seen before. So UUID, the actual field of UUID, and that equals to UUID.UUID1, just like that. So let's go ahead and import UUID. And we could totally make a copy of that data as well. So data equals to the dict of that data. Should make a copy of it. This time we don't have a schema validation error. But it actually is a really nice and clean way to ensure that the data we have coming through is correct, right? So we should probably write a bunch of tests to ensure that and ensure that it's at least clean here. Now we actually have to keep in mind that if we do need to add new columns, we need to do it in two places. One in the place where we're validating this data, the other one in the place where we're actually going to go ahead and end up storing it. Now, the cassandra-driver itself can validate data, but the thing it does not have built into it is this e.json. And it doesn't actually work directly in FastAPI. FastAPI was designed to use Pydantic as a validation tool in any given response or view. So we're really actually pretty well set up to start actually building our views so we can actually see what it looks like. Now we're going to go ahead and implement the FastAPI application, at least the basic one, as well as the environment variables. So inside of our app, we'll go ahead and do main.py, and I'm going to import from FastAPI. We're going to import the FastAPI class, And then I'll go ahead and declare the app itself with FastAPI. And then we'll just do @app.get/ and define read index and return a dictionary of hello world. Now, if you've never used FastAPI before, this is it. This is a web application right here. So to actually run this, we just open up a terminal window. Of course, make sure your virtual environment is activated. I still have Jupyter running, but you don't have to if you don't want to. And then I'm going to go ahead and run uviacorn and app.main:\app. Now, uviacorn is the web server gateway interface that we're going to use. App, of course, is this folder right here. Main, of course, is this Python module. And then the final app right there is what I configured here. So, of course, if I called this ABC, I would need to change that accordingly. And so I'm also going to do -- reload in here. And, of course, this is going to open up a new web server for me. So I can open that up and I see hello world. Now, that's fine and all, but we actually need to add in the environment variables for this. Right, so the way I have it set up before was I actually loaded in .env and I actually have it set up this way. That actually doesn't work in this case, which is another reason to have Pydantic installed, because it actually has a really easy way to use our environment variables inside of our FastAPI project. And that's what I want to do now. So inside of this app, we're going to go ahead and make a config file. So config.py. And I will go ahead and import a couple things. First off, from Pydantic, we're going to import the base settings. And we're going to also import field, the actual field class. So I'm going to go ahead and declare a class called settings and take in base settings. And the settings I for sure need are related to our database. That is our client ID and our client secret. I probably don't need anything else. The only thing that I could consider grabbing as well is the actual key space if I did want to change that to being an environment variable. So that's completely up to you on how you want to go about doing that. I'm going to keep things nice and simple and just do DB client ID. This, of course, is a string, and then DB client secret. This is also a string. Okay. So the reason I actually imported field is so that I can actually map whatever these values are to what I would have in my environment variables. So these values right here. So client ID and client secret. So to do that, we are just going to go ahead and say equals field, or rather field, and then ... env equals to that. Okay. So the ellipsis allows me to just write in whatever defaults are and then go here. And then I'm going to go ahead and do this same thing again. This first one should have been actually client ID. Right, just to verify, let's go ahead and grab that one. And there we go. So these are our baseline settings. The next thing I need to do is actually add class config and then do env file being equal to .env. Okay, so it's going to go off of that .env file, but that all depends on where I'm actually running this uviacorn. So if I actually ran uviacorn inside of app, as in just simply main:, then I would make sure that my .env file is inside of this app file instead of in the root of my main project here. But I'm going to go ahead and leave it just like that. And so the next thing is to actually get these settings items here. So we're going to define a method called getSettings, and I'm going to return an instance of this settings class right here. So one of the things that we don't want to do is run this every single time. So Python has a built-in method to prevent that from being run over and over and over again. So we're going to just go ahead and do from functools, we're going to import LRU cache so that it actually just kind of keeps that in memory. And again, it's not actually grabbing it over and over and over again. It just does it the one time, which is really the only time we need it is at the beginning, right? So these environment variables should not change on the fly very often. But I will say that it is possible that this environment variable is not in your environment. So I'm going to go ahead and change this actually back to 1. I should have had it in as 1, as in true. I'm going to go ahead and add in one more thing in here and just copy and paste it. So I'm going to import OS and literally just say if that variable is not there, just set it equal to 1 because it may or may not be there. And this is just a key to make sure that it is. Cool. So now that I've got this, I'm going to go ahead and add in one more thing, and I'll just go ahead and call this project name, and I'll go ahead and say FastAPI cassandra-DB or AstraDB. Let's just call it Astra. Okay, cool. So there's our project name now. So I'll just go ahead and say name is the string, and that's equal to the field, ... and env equals to project name. Okay, cool enough. Now I'm going to go ahead and grab these settings inside of my project here. So to do this, I'm going to go ahead and do from dot import, and I'm going to go ahead and import the config module itself, and then declare settings equals to config.get settings. So if you ended up calling this module settings, which you totally can, just make sure you're not importing settings and then resetting settings everywhere, settings. Just kidding. But the idea here is we now have these settings here, so I can actually declare them and use them, right, throughout my application. So this is going to be, let's say name, and this is just settings.name. Just a really simple example of grabbing one of the settings items in there. And this should be func tools, not just tool. And there we go. And this should be a string. That is why we actually run reload, is it will automatically check all of our code for us. And if we refresh in here, now we've got that name showing up. So it's probably fair to say that all of my secret keys, all of the environment variables are working correctly. So this of course means that our database file, so db.py, will likely have to change at least slightly. Now inside of db.py, instead of using a load.env, I'm going to go ahead and use that configuration file again. And so we'll go ahead and do from dot import config, and then settings equals to config.get settings. So notice that I'm calling it again, and in that last one we used rlu cache, so that won't actually run it again if it's ran the first time. And so I could do a couple things here. I could use the environment variable in this way, or I could just simply do .db and client ID, and then db.client secret. And again, we just want to make sure that that's exactly what it is inside of these settings and everything is set up correctly. I think it is. We'll find out in just a moment. I'll get rid of that load.env now, and I'll save things out. So at this point, I'm going to go ahead and just jump into Jupyter. Now, I actually may have needed to change environment variables. So if you did need to change environment variables, when in doubt, close down your Jupyter notebook, deactivate your virtual environment, and then reactivate it, and then run Jupyter notebook. That is often a clean way to fresh out environment variables or flush them out. And so I want to just jump into my notebooks here and go off of any of these, and just to verify that everything is still working based off of this session. And right here, I'm getting that I don't have something called DB client. So clearly I made a mistake. I did db.id, when it should be db client underscore ID. Okay, simple enough. Restart and run all. And here we go. Looks like we're doing okay so far. I didn't see any big errors yet. And sure enough, it actually still works. So we certainly could have done that method from the get-go, but it actually only really makes sense when we start to bring it into FastAPI, because environment variables can work off of just that load Python or that .env module. In fact, it still is working off of the .env module. It's just working through Pydantic to make that happen. So this is all good now. I actually shouldn't have to change a whole lot here. So the next thing is going back into main.py and configuring a new kind of route. Well, really an event handler for FastAPI. So what we can do is I'm going to go ahead and import the database itself, and I'm going to go ahead and declare a session being none. And then I'm going to go ahead and say on app.onEvent startup, I want to actually define a method called onStartup. And the reason for this is to have a running session of our cassandra-driver so that we can actually access AstraDB in our session here. So we'll go ahead and say global session, and our session itself is equal to db.get session. And of course, in this case, DB is the database module. So if you have to import from DB or from .db, we can import get session here as well if you needed to, and just call that, right? Just so you know if there's any name spacing issues. Okay, so that gets our session, which is nice. There's one more thing that we need to do, and that is something we've already seen before inside of our database file itself. So inside of CRUD, we had this sync table here, right? So we actually do want to sync this table. We don't necessarily want to do it inside of CRUD. We want to do it inside of the main.py, okay? So I'm going to go ahead and comment this out. This should actually create a new problem for me somewhere, which I'll explain later. But I'll go ahead and comment all of these out. We no longer need that session in here. I'm going to get rid of it in this CRUD file altogether. And really the CRUD file itself should actually just be literally that. That's it, right? Just the model, everything related to it, and also no more sync table. Okay, so back into main, we'll go ahead and bring in sync table here. And of course I need to bring in my models as well, because what I'm going to do here now is I'm going to run sync table models.product and sync table. And there's going to be models dot, I think we called it product scrape event. There we go. Very good. So far we have a session. We then sync that table from that session. That session, of course, is setting a connection and a default connection here. So now what I want to do is just respond back with a query set of some kind. So what I'm going to do here, just to keep things nice and simple for me, is I'm going to go ahead and say read products, or really the products list view. And I'll go ahead and go into products here. And what I want to do is I want to use the product model itself. So I have it in here like this right now. I'm actually going to redeclare it as product equals to that product model. And that way I can save myself some typing here everywhere. Of course, I could obviously import each one of those individually anyway. It's kind of up to you on how you want to design that. But here we go. So now let's actually turn our product list view in here. And I'll just go ahead and say results equals to, well, we've already seen this one, and it's list the product itself objects.all. Okay, so that's really, really close, right? Let's actually see what happens here as the result. Now going back into our FastAPI app, it's still running. So let's take a look at it. And I'm going to open this up into a new window here, go into products, hit enter. What do you know? It's actually giving us all of those results. That is fantastic, right? But what if I only wanted to show the ASIN and title, for example? Well, this is actually where I can start using my schemas, right? So I have this product schema here, and perhaps this is it. I just want ASIN and title, no price string, right? So let's go ahead and grab that. And I'm going to come into, or actually, let's go ahead and do one more schema in here, and I'll just call this my product list schema, right? Because perhaps I want to bring that the actual price string back in based off of my model itself, right? It would make sense to have it. Anyways, so back into our view, that is what I want to change this result to look like. So to do this, we're going to go ahead and add in our schemas as a import here. I'm also going to go ahead and import from typing, we're going to import list. And what I can do on any given decorator for the route that we're handling, I can add something like this where it's response and model, and it can be equal to some sort of value. So in my case, it's going to be equal to the product list schema, but rather a list of the product list schema, just like that. And so if I save that and refresh in here, what I should get back is the results being, well, close to this. But unfortunately, the way it's currently set up, it's not actually going to give me the correct results back. So let's go ahead and cut this out and literally just return back a list of items here like that. Not in a dictionary, otherwise we will probably get an error here, and it looks like I am. Oh yes, and product list schema is also not defined. So let's go ahead and do schema dot product list schema. And let's run it again. I'll break this down so we can see everything here. So far, so good. Refresh in here. And this, in theory, will bring us back that product list schema. Looks like it got it, looked it up, and there we go. Right, so at any time then, I can jump into my schema and add in the price string, again, as an optional string. We save that schema. We refresh in here, and now it's going to also not just validate that data like we've already seen, but it's also going to display it, right? Instead of displaying literally everything that's in our model, right? Yet another reason to use Pydantic. We did it for validating, but also for sort of serializing the data we want to display, which I think is pretty cool. Pretty neat, actually. And so now what I want to do is take this one step further and grab this product scrape event schema. This time I'm going to go ahead and do product scrape event detail schema. So it's going to be pretty similar to what we've just seen, but this time no UUID. Okay. So in other words, I want to actually now have a new view for an individual product, right? And based off of ascend. So I'm going to go ahead and copy this. And we're going to paste it down here. And this time I'm going to go ahead and change the response. I'll just get rid of the response model for now. And then we'll go ahead and pass in ascend in here. Now, the way this works is very similar to doing string substitution, but instead of doing string substitution, it's going to be doing string extraction. And so that actual value will go into this function right here. So this is going to now be our product detail view, right? And so one of the things we could do is we could just have our schema coming back with the product itself, right? So we could do product.objects.get and ascend equals to ascend. And of course, that's not actually a list anymore, so we can actually put this in as a dictionary. Okay, so we save that and make sure the server's running. Jump back in here, grab one of the ascends in here, hit enter, and what do you know? There we go. We now have a detail view for that. That, of course, is all of the data. And so what I can actually do is say the data is equal to that. Return that data, of course. I can also add one more thing in here called events or something of that type. And now what I can do is, yet again, using a list, this time based off of the product scrape event .objects.filter, and again, ascend equals to ascend. This should be initialized. Okay. And so this is going to give me a list of all of those product events. At least it should. And then we can refresh in here. And what do you know? It's actually giving me a list of all of those items. That is pretty cool. But I don't want that UUID here. So all we need to do then is pull this out and say events equals to that. Then I want to use our schema, the product scrape event schema. And we'll go ahead and do events again. This time it's just going to be simply that schema with the data itself. So for X in events, and then come back with that. There we go. And we refresh in here. And we got a server error. Let's see what's going on. Oh, that actually is not imported. So we'll go ahead and use schema dot. Now it should be good. And if we refresh in here, we have that data as we wanted it to see it. Pretty cool. And so the other part of this, of course, is in the schema, perhaps, again, we want to have that price string all around. And so we can just change these things on the fly, which is exactly why I like using the Pydantic for rendering things out like this. And so now every time going forward, I would be able to actually see every one of these things being scraped. So if I actually did open up my Cassandra models, this is still something I'm going to need to solve. So I'm going to go ahead and solve it right now in the sense that if I restart and run all, what's going to happen is we're going to get an issue with trying to use one of these data models, or at least in theory we would. So the reason it's not actually working right now is likely because we have a session running. But if we didn't have this session running, what we would need to do is come in to our main project here and actually call these things right here, right? So let's go ahead and give that a shot. We'll bring in main, get our session here, and then call on startup and see if that actually will run those things. If it doesn't, then we would just want to call this every time we run in there. Oops, this should be main on startup. Okay, and so that should actually set the sync table correctly in there. And so now for sure, when I run these events, they should work just fine. It's certainly possible that they were already running, but if I took down FastAPI, it's a good chance that they aren't running anymore. But now that we've got this, we should see quite a few more, right? Now, the last thing about this event is I actually do not see the timestamp here. And so what I want to do now is I want to actually use my Pydantic stuff, the actual schema itself. I want to help this so I can actually see the data that I want to see in terms of a timestamp related to that UUID 1. Looking at all of the different scrape events, there's one critical flaw to the current data situation, and that of course is it's missing the actual time this occurred. Like, did it occur a week ago, a year ago, 10 seconds ago? We have no idea. Well, actually we do. So if we actually look at our model itself, we have this UUID field. And in this case, we actually used UUID.UUID1, and that of course has a time element to it. Now, cassandra-driver, you actually could have used the time UUID field, and actually these two essentially are doing the same thing in our case because we are creating this UUID field. So by all means, use either one. But in this case, I'm going to go ahead and actually parse this UUID field into an actual date and time object. So to do this, there is a gist that I created specifically to handle this challenge. So if you go to gist.github.com/codingforentrepreneurs, you can find the Cassandra time UUID to Python Datetime markdown file. And this gist right here at the very bottom, this is it. It's really, really simple. So if we just grab this and jump over into our schema here, actually I'm going to go ahead and create this as a utility function. So we'll go ahead and do utils and paste this in here. Really, really simple. So even if you pause right now, you could probably get the gist of it. But the idea is we use a datetime object. It's kind of strange. The starting date is October 15th of 1582. There's an interesting article, so by all means, check that one out. And then we're going to go ahead and get the remainder from the time that we pass in here divided by 10. So this is actually the way to convert a UUID 1 time to a datetime object, right? So it gives you an example right there. It's not really that complicated. The part that you might be new to is actually implementing this or augmenting one of our fields in here. So what I want to do is I want to actually import another thing from typing and have an any type here. Now, the reason I have an any type is, well, how I want to actually represent this value. So again, I'm using the product scrape event detail schema. I'm going to go ahead and say created, and this is going to be an optional value of an any type, and we'll go ahead and say none. So with this, what I can do is I can actually use what's called a root validator in Pydantic. Root validator, just like that. And what this will allow me to do is to actually enrich my values. So if I use this root validator with pre being true, we're going to go ahead and define, and I'll say extra create time from UUID, right? So essentially, I'm just going to go ahead and assume that this time from the UUID is going to be the created time, right? So in my case, it certainly is, but it's possible that you didn't do it that way. So I'm going to go ahead and add the class value here and values. This is the standard operating for this root validator decorator. And so what I just need to do is add the key value pair that I want to add. So in the case of values, I'm going to go ahead and add the created field here. And I could start off by setting an equal to values of UUID and then return those values. So what this is doing is just adding an extra arbitrary field to my validated data, which we could verify in our project. And there it is, right? So of course, this is that UUID. We need to change that with our new utility function here. So to do that, well, we can actually call .time on here. And I'm actually very confident that it will give me the correct value, or at least that the UUID will never be none. Because the data that's coming in here from the model itself, the UUID is the primary key. It definitely is going to be in there. Of course, if it wasn't definitely going to be in there, I would probably want to have some conditions with this. And so what I want to do now is actually bring in that utility function. So we'll go ahead and do from .import utils, and then just simply wrap this as utils.uuid time to datetime. So you do have to pass in that time there, and then we're going to go ahead and refresh this, and there is your datetime object. Now you can also do a timestamp here if you were interested in having the actual timestamp as this value. Timestamp is not just .timestamp, but rather timestamp. And we bring it back, and this will give us that timestamp value. So you could kind of pick and choose which way you want to go about doing this. Now, you will notice it does take a little while, and it will take a little while based off of this data. In other words, actually enriching this data does take some time because it's going to be parsing these things out and doing all that. So the next part of this is I just want to go back into main where the view is, where I'm actually getting this data, right? So the events right here, and I want to limit the amount of items coming back. And that's really simple. We just go on this query set here. I'll break it down a little bit and just do .limit and limit the number that you actually want to show. So if I said 5, that should be fine. I refresh in here, and this will give me now the most recent 5. So what I would do to advance this is I would actually add one more view and say events, or slash using the async / events. And this time I'm going to go ahead and use that response model again as a list. And we would come in here. This time, of course, it's going to be our scrape event as our response, which I don't have to, or rather the scrape event detail here. And again, we can still have this list coming back, but now we could work towards actually using pagination. I'm actually not going to do that right now, but we can actually do scrape events list view. And then that way, if we did want a lot more data about any given event, this would be the way to do it. And if we did pagination, then we would be able to limit each one going forward as well. I think this view is quite a bit more simple than what we had up here, but it is nice to know that we can do both of those things. And so at that point, then I would just say event, endpoint, or maybe like the event's URL, and set that equal to basically this string right here. Right? And of course, whatever domain you end up using. And then that way on the actual detail page, the user would know about that, right? And so if we collapse that down, there's our events URL. That's pretty nice. So if we actually wanted to extend this, granted, we could take a lot of time doing it. And I will say one of the things to consider, in all honesty, is to not actually convert this on the fly like this, but rather maybe convert it at the beginning, like as in the model itself, like put in just the timestamp itself as another field. So that when you actually perform CRUD, when you create this entry, you add whatever that is as well. So that is going to be certainly a lot more efficient than doing what I just did, because it's going to be in the data itself. But the reason I wanted to show you all of this was to show you several steps to get there, right? Actually enriching your data a little bit more is something you might end up wanting to do, as well as actually going off of, maybe the actual product schema itself. You could enrich the product scrape events from that product schema in theory. I don't want to actually spend the time doing that. But the idea here was we actually did some adjusting to a Pydantic actual base model, the schema that we created there. We use this utility function and something that's very, very common inside of the Cassandra database. Now we're going to go ahead and create an endpoint to ingest data. That is, I'm going to allow pretty much any source to scrape this data right here and send it to my FastAPI project, which will send it to our Astra DB, of course, our Cassandra database. And so what we want to do is really simple, actually. If we look at the schema that we want to use, it's this one right here. This, of course, corresponds very well with our CRUD action for this scrape event, right? So we definitely want to put that one in. And then we actually want to update a endpoint for this. Now the endpoint I can use is literally this one right here. It's going to be very similar to that right there. But what we don't need to do is have the same endpoint. I'm just going to call this events/scrape, right? Simple enough. The response model, I actually don't need the response model in here, but I will use the actual schema still. And I'm going to go ahead and say data is of the type schema, that actual schema data right there. And of course, this is going to be the events and scrape create view, right? And so we're going to call CRUD. So we need to import that. So import our CRUD options here. And then we will just use that data. So we'll call the, I don't remember what the response is, so we'll just go ahead and do CRUD dot. And then we'll grab the add scrape event here. Then we'll grab this data, which is the dictionary, right? So that's going to be validated to the Pydantic model here. And then what gets returned back is a product object and a scrape object, both of which we could still use. And we could actually roughly put it together like this, right? I don't actually want to do that. I'm just going to go ahead and return back the single product list schema item, which is really just that product object. So the scrape object I'll just leave as an underscore, just like that. Cool. So now that I have this endpoint, it's actually time to test it out, right? I shouldn't have any errors on the FastAPI portion, and I should still have my Jupyter notebook running. If you don't, by all means, just run it into a new server itself. And so inside of our notebooks here, I'm going to go ahead and create a new Python module here. And we're just going to call this send data to scrape event URL or endpoint. And of course, this is going off of our local host. So first off, I need to import requests, Python requests, to actually send an HTTP request here. And of course, if you don't have that, just run pip install requests on a different cell without the hashtag in there. And then our endpoint is going to be that, right? Actually, not that. It's going to be events/scrape, okay? And we need to make sure, we have the wrong method here. This should say host. Okay, so there is our endpoint, and we've got our endpoint here. And so the data values, well, let's actually just call it as is. So requests.post to that endpoint, and we'll just say JSON is just an empty dictionary. And we'll print out r.json. And we run this, and it says a value error missing, right? So we're missing the body and the ASIN here. Okay, so we're missing the actual ASIN as the primary thing that's missing. And so we can go ahead and just grab an arbitrary one or just test this out. So I'll go ahead and add it with ASIN, and we'll go ahead and do HTTP test, and I'll give it a title of, ABC123, and then a price string being another one, or rather, let's do a proper price string like that. We post it back, and what do you know? There we've got. If I do it again, and again, and again, and again, it's always going to be that data. So of course, now what we can do is, still using requests, we can actually look up this data. Let's see if it even came back by going into products and then the ASIN that I used, which was HTTP test. And now we'll go ahead and call this just endpoint 2. And then R2 equals to requests.get endpoint 2, and then R2.json. We'll print out R2.json. Okay, oops, that should not say HTTP test, but rather ASIN, and then put the ASIN equal to that original one that we had up here. That would probably be nice up here as well. Cool. And now we run it, and what do you know? We get that same data coming back. And of course, it's going to grow. If I keep adding stuff, it's eventually going to grow. Except, well, in this case, it's not. But if we go into events, which I did not paginate, it should actually give me all of them. And it will just continue to give me all of them. Or at least it should, right? So it's certainly possible that it's going to stop. Maybe I actually didn't update the limit. Let's go ahead and check. I certainly did leave the limit in here. So I'm going to go ahead and get rid of that limit, and we'll take a look at it again. I actually don't have to refresh anything. I didn't mean to do that. But now if I refresh the GET request, I see it coming through. So I did mention you could do this anywhere. And that's actually the point, is I want to be able to do this anywhere. So to do that, there's a tool called ngrok. So if you do ngrok.com, just like that, and download this tool, what you'll do is you'll open up another process on your machine and run ngrok HTTP and then the port you're running FastAPI on. In my case, I'm running it on port 8000, which I could see again by just rerunning it. And I see it's on port 8000. Of course, this is also true by just looking in the URL itself. But now when we do this, I can actually use the ngrok base point or the ngrok base URL, which is listed right here, right? So I can actually use that. Either one doesn't matter, right? So one is HTTP, one's HTTPS. So I can go ahead and grab this and come back into, well, I can open it up and notice that it says hello world. It's all of our FastAPI stuff. But I can also go into my Jupyter notebook here and say base URL is equal to that. And then the path is equal to, well, which path are we trying to use here? And that's the events scrape, right? And then our endpoint now is going to just be combining those two. So base URL and path. And so yet again, I'll just go ahead and post some data based off of that endpoint. And I can continue to do this, and then go ahead and do that quick look up there. And we'll see a lot more data. The best way to tell is to put the length there, and it's at 16. Let's go ahead and run it a couple more times. Now it's at 20. Pretty cool. And so that is a really simple and easy way to ingest new data through FastAPI. And now to me, it's not about actually using our local Jupyter notebook, but rather to use something like Colab. And if I'm like, oh, well, something seems to not be working correctly. So let me open a notebook here, and we'll talk about doing the proper scraping later. But I'm going to go ahead and call this right here. So let's go ahead and import requests here. Colab itself is a Jupyter notebook, and it allows you to run all of the same things as your local Jupyter notebook. A lot of things are already installed in here, but of course, if you needed to install anything, you would just do pip install abc123. You can also use apt in here for Linux installs, so apt-get like Selenium or all sorts of things in there too, which is cool. But now, if I call this, remember, ngrok is an actual endpoint. This is out to the world. I run that, and oops, I don't have asyn in there. Should have left it in that other cell. Okay, so there we go. And I run this again, and again, and again. This is literally a live production server going to ngrok that goes to my local server. Now, do keep in mind, ngrok is, well, it's pretty secure, but it's probably not the most secure possible. And the other thing about ngrok is when I close it down and then rerun it, you're going to have a different URL. So it's not necessarily the long-term solution here, right? It will give you something like this. So you'll definitely need to update your ngrok endpoint. Now, one of the ways you could do that is by putting just like input here and saying like, what is your ngrok URL? Something like that. And then just, copying this and coming in here like that. There you go. I am not going to do this, right? I'm not actually going to be using ngrok in the long run to do this at all. I was meaning to show you this only to show you that it can be done, and it is a certainly effective way to work off of our FastAPI, and yet another reason to just have FastAPI running a lot of our Cassandra database stuff, because it gives us this endpoint that we can now work with in many ways, not just to update data, but also to actually see that data, to scrape it, to look at it, all sorts of things, everything that you would need to do. Now, of course, this is only a big part of it, right? So what we do want to do at some point, not in this video, but what we do want to do is actually submit this to a production server to actually work on production. But the reason that we aren't doing production in this series is related to this connect.zip here. Now, there is a way to encrypt this and make sure that it's going into production securely, but it's just adding a lot of steps to something that doesn't need to happen at this time, which is why I wanted to show you ngrok as well. But now that we've actually accomplished this, we've done pretty much all the things that we want to do in terms of storing our data, like actually getting the foundation done, right? So if we want to add things to it in the future, we might do that, as in adding fields to our model and updating our schema accordingly, and maybe even the different URLs that we might have. But actually what we want to do now is we want to implement Celery. We want to actually start having a worker process that's going to actually run on a regular basis for us. Now we need to talk about creating a worker process. And the logic goes something like this. You look at a function, in this case, hello world, and then when you want to run that function or execute it, you just call it. But the question is, what if I actually wanted it to be fully executed in the future? Whether that's in 1 second or in a week or in a year, how do I actually do that? The other thing is, what if I wanted this specific function to run every Monday at 9 a.m., right? That is actually what we're going to be using Celery for. So Python Celery is how this actually happens. You're able to use it to both delay tasks from running and also to schedule those tasks. Now, the cool thing about delaying the tasks is it actually can be ran on a multitude of computers. In other words, you can have a huge cluster of computers running these tasks for you. You don't have to use your main web application computer or the current computer you're on, which is really, really cool. Granted, you need the code and it would all need to be set up correctly, but that's actually what you could work towards. Now, we're not going to be doing that complex of a thing yet, but the idea here is we're going to implement Celery. Now, Celery itself relies on communicating through messages or a message broker. That is why we're going to be using Redis. Think of Redis as a big key value store that your Celery application is going to work. When I say key value store, I mean just like a huge dictionary. It has a bunch of things in it. It's going to run these keys, and then Celery is going to manage this process for us. So it's going to insert keys and then delete them on its own without our intervention. But we definitely need Redis to work. Otherwise, Celery won't work. So at this point, I do recommend that you set up Redis on some machine, whether it's your local machine or a remote host. Now, on our repo in the setup folder, we have an entire guide on how to set up Redis on a variety of different machines. So if you just want to get things going, create a virtual machine on some cloud host and run these like 4 commands right here, right? It's 5 commands. It's really, really simple, right? And then you're going to ping it. That's a really quick and easy way to get Redis going. Now, if you're on a Mac, you can use Homebrew to install it. But if you are on a Mac or a Linux, I recommend using Docker. It's so much easier to just run it with Docker for a couple reasons, which I'll show you in just a second. Windows users, if you can install Docker, use Docker. Otherwise, there's a tool called Memory that you can use that is exactly like Redis. So yeah, a lot of options here. So now I'm going to assume that you've already installed Redis on your system and you can actually ping it. So one of the ways to ping it is like this. Now, the reason I like this way is because I can actually change the host right here on this pinging, and this doesn't actually rely on any other third-party technology at all, unless, of course, if you're on Windows, then you might not necessarily have this. So you might have to use Redis CLI and ping. Okay, so in my case, my Redis server is not actually up and working, at least at this port. So what I want to do is actually run my Redis on Docker. And it's really simple. I do docker run -it-rm. This means that it's going to run it in interactive mode and it's going to remove it. And then I can just call Redis. Just like that. That's the official image right there. And what do you know? There it is, right? So that's actually pretty cool, I think. So now what I can do is reping it, right? So Redis is running up there and I call that ping again and I'm having some issues, right? So notice the port. This is why I really like Docker. My local version of Redis is not working correctly, but it's also not connecting to my Docker version. So I'm gonna go ahead and close this out with Control-C, press up again. And now what I'm gonna do is I'm gonna map new ports here. So -P for port. I'm going to expose 6380 to the internal port of 6380, and then I'll just call Redis and then --port and 6380. We hit enter. There is our new port here. And so if I want to ping it again, I can do that with just simply a different port, and now it gives me a response. I can also do this with the Redis CLI. I can ping it with changing the host or changing the port. So if I change the host, I could change it to localhost this time and just do port being 6380. Hit enter. And in this case, it's actually not pinging it back with the local host. So let's go ahead and put it at 127.0.0.1. And oh, that is also not pinging it correctly. Let's actually change the order of the ping. Localhost should have worked. I should put the flags in first, I think. And that's what it was. Okay, so that is not being able to be seen. There we go. And so the idea here is we just need to make sure that I can run these commands somehow, right? If you can't do it, the rest of this is not really going to matter at all. So with this in mind, I'm going to go ahead and use this as my actual Redis URL. So let's jump back into our project, into our environment variables first, and put in your Redis URL just like that. You can use localhost, you can use an IP address, right? So like if you were going to deploy this on some server, which I actually definitely recommend you try out. It's really cool to see because you just install Docker and then run it and then it's boom, it's ready to go. Then you can always delete that virtual machine at any time, which is awesome. Okay, so like if you're using DigitalOcean Droplets or Linode or AWS or GCP or the many places that you can actually use virtual machines. Okay, so I'm actually going to leave my Redis URL like this. Okay, so now I need to actually use this Redis URL. Notice I haven't configured anything related to Celery just yet. I want to actually bring in this Redis URL into my main configuration for Pydantic. Now, Celery itself does not need Pydantic. I'm just using this as a way to load in virtual environments. So in here, I can actually declare the Redis URL very similarly to what we've done before, which is adding a field, making it required with the ellipsis, and then declaring the environment variable mapping. In this case, I'll just go ahead and say Redis URL. I think this is actually a bit redundant. We could probably just leave it as Redis URL because it will map to the uppercase version as well. Cool, so we now have that setting. Okay, so since we're all set up with Redis, I shouldn't have to do anything else. We'll see with Celery itself in the future if I need to do anything else. And I also want to make sure that Redis is always running, right? When I am using the worker process, I need to make sure Redis is running. I'll show you little strategies on how to ensure that it is running, or at least know what to look for if it's not. Okay, so we save it, and let's go ahead and create our app here. This is our worker.py. So I said create an app because this is a Celery application. It does not need anything else to run. The only reason I have configuration like this is to load in the environment variables. I could absolutely do this exact same thing all over again individually for this worker process. I just don't need to. So let's go ahead and do from Celery, import the class of Celery, and then we'll go ahead and declare app equals to Celery, and then we use the name of the module. Cool. And so we could leave it like this, right? I could actually use the app here. Now, the reason I'm not doing it in this project is because my primary application is actually my FastAPI application, which is also declared as app. I don't want things to get confused, especially when it comes to the decorators, which we'll see in a moment. So instead of using just simply app, we're going to use Celery_app. This gives it some distinction that it is a Celery app because of how we define tasks. So let's first off define a function, and we'll call it random task. Give it a name or some sort of argument in here. It could be any argument. We'll explain that in a moment. And we'll go, who throws a shoe, honestly, and then put their name in, right? Silly function. But now we want to actually turn it into a Celery task, and we use the decorator Celery app. Of course, it's whatever this is named, .task. So you can see if I actually called it app and app.task, you might actually accidentally look at this function, look at your primary app and be like, oh, this is a FastAPI decorator. It is not. It is a Celery decorator. Cool, so we're almost there. Not quite, but almost. Now, typically speaking, you will see this a lot where it says Redis URL is equal to just Redis : //127.0.0.1 /6379. You'll see this a lot because that is the default Redis port and host. Sometimes you'll see this as localhost, but that's the default. And then you'll see Celery app.conf.broker URL is equal to that Redis URL. This is letting Celery know, at least for the worker process, that this is the Redis we want to use, or at least the broker that we want to use. You'll also often see the result backend being stored in Redis as well. Okay, this could be completely different as well. You can put it into a SQL database. You can put it into Cassandra. A lot of places you can put the results. We're not going to worry about that right now. But the idea is you'll see this. And you might remember I actually made a configuration item for this, right? Specifically for environment variables. So this is the method that I used in my primary app to get environment variables. So I'm going to use it in all other apps that have access to the same code. So we're going to go ahead and do from .import config. And then, of course, our settings is simply settings equals to config.get settings. Of course, we've already seen this before. And now our Redis URL is settings.redis URL, just like that. Exactly what this is. Okay, simple enough, I think. And now let's go ahead and run this. Okay, so I have the Jupyter Notebook running, or in this case, it's FastAPI. I also have my Jupyter Notebook running, and I'm going to go ahead and run my Celery application now. A lot of processes running at this point. To do this, we can call Celery itself, or you can call python-m Celery. Either one gives you the exact same command. So Celery -app and -a do the same thing. I'll leave it in as -app. And then we go app.worker.celery app. So app of kin is this folder, worker is this Python file, and then Celery app is this variable right here, which of course could change. And then we just call worker. And then we can actually use log level, which is the same thing as doing -l, but --log level and info will give me info about what's running. Okay, so it's running. Notice the Redis URL here. Okay, so that's exactly the Redis URL we configured in our environment variables. All right, and also in Docker. Now let's pretend for a second that you actually did not have, like maybe you forgot to run Docker, so you close this out. Now in our worker, if we scroll down a bit, this is what happens. It actually loses connection refused. Okay, so if we run it back up, then it should be able to regain connection, which is just so cool, I think. All right, so let's actually go ahead and do an example using a worker task, this random task here. Let's actually take a look at an example of that. Now to do that, I'm actually going to go jump into my Jupyter Notebook here, or Jupyter Notebooks. And I'll go ahead and just duplicate one of these notebooks. Let's duplicate working with Cassandra and Pydantic. just for some of the boilerplate that's in there. And we'll go ahead and rename it to working with Celery basics. Okay. So let's jump into there. And what we want to do, of course, is from app import simply worker. Okay. We don't need UUID and we don't need a lot of these other things. So edit and delete cells. Okay. So the function name was simply random task. Okay. So actually what I'll do is I'll actually import random task just to make it really clear and really easy to see what's going on. So random task, and I'll pass in Justin. I run that. Oh, let's make sure it's defined. And there we go. Who throws a shoe? Honestly, Justin. How silly is that? Okay, so Celery wasn't used at all. That's just a standard Python function right there. So how do we actually use Celery then? Well, what we do is we call .delay and then pass in the arguments. It's really just that simple. Now, though, inside of Jupyter, we see a task result. This is the actual task ID and the result for it. Or this is the asynchronous result for it. So we can actually look that up somewhere else if we needed to. But if I actually go into Celery, the Celery process, there is that printed statement. Let's do this several more times. So I'll do for I in range. Let's do it 10 times, something like that. We're going to go ahead and delay this task, run it. Look how fast that was. And if you go in here, if you scroll down, it actually shows us that. Now, we can make this a little bit more explicit to what that iteration was by coming in here like that and scrolling down. We now see each one of those tasks iterations coming through. So that's pretty cool. This is actually a simple way on how to delay it. Now, there is another way, and it's called apply async, just like that. And what we want to do with apply async is now we actually pass in args, and these arguments should be in a tuple, just like that. And then we can also do countdown and maybe like 10 seconds, right? So what this is going to do then is very similar to delay, is it's going to wait 10 seconds to execute. In fact, delay itself just does not have that countdown in there. If we comment this out, that is now exactly what delay is, right? So inside of here, I actually need to put a comma there, like that. You want to make sure the values inside of the arguments are a tuple as well. Cool. So now let's give it a shot. I'll run this. And so what's going to happen here is it's going to take some time to actually run these. Notice that the actual Celery worker did get these random tasks here, right? So these tasks were received, and then it actually will start running them. But it doesn't necessarily run them in perfect order, right? It runs them when it can. It is mostly in perfect order, but 1 actually went first and then 0. This all has to do with how the worker process sort of distributes task to itself in this case, because it doesn't have more machines. But now we can actually run Celery and delay tasks later. This is going to be really important when we actually start to schedule tasks or run scraping when we want to, and then storing it into a Cassandra database. Unfortunately, we can't just run Cassandra as it stands right now inside of Celery. We have to do additional configuration specifically for that. Now we're going to go ahead and integrate Celery with Cassandra. Now, the way this actually is going to work is we're going to define a Celery on startup method that will go ahead and just collect all arguments that come in here like that. And for now, I'll just go ahead and print out hello world. Okay, so this we want to trigger every time Celery starts. Now, this is really good for using Cassandra, but you can do this for all sorts of things. So if you need to actually run some sort of long task before a Celery worker or a beat server starts, you can do that right here. So to actually wrap this into Celery, we're going to go ahead and import the signals for it. So from celery.signals, we're going to import 2 different signals here. One is the beat init signal. The other one is the worker process init signal. Now the beat signal is for scheduling tasks. We'll do that later. But for now, we're just going to focus on the worker process itself. And we'll just go ahead and connect both of these things to our now startup method. Now, if you look at this, it's actually not a whole lot different to what we did with our FastAPI application, right? It actually has a function here that we can call at any time. And in there, we're going to essentially do this. It's going to take a few more steps to get there based off of Cassandra's documentation. But in our case, we're going to go ahead and first off start just like this. So let's save it. Let's run our worker. And what we'll see is a bunch of print statements for every single worker that's inside of Celery. In this case, it's 16 workers, which is pretty nice. We can actually use this all throughout. And so when we actually call a task, it's going to pick a different one, which we can verify by going into the notebooks themselves, going into Celery Basics, right? If we run this here and delete all of those different tasks, we should see various workers coming through, right? It's not always going to be the exact same worker. Now, when it comes to Cassandra, it actually most likely will be the exact same worker because of how we want to set this up. Like, I don't need to have 15 different workers on the same persistent connection. We just really need one connected, but we definitely need to connect it. So to do this, we are going to go ahead and import a couple things from our configuration. So the database and our models. And so the initial thing would be like, oh, well, maybe I go ahead and do session equals to db.get session. Now that seems like it's okay, but unfortunately what happens is it doesn't connect the correct way, right? So we actually need to redo this inside of that Celery init method. So what we're going to do instead is get the cluster itself. Okay, so let's go back in here. And instead of doing session, we'll do cluster equals to db.get cluster. And now we'll go ahead and declare our session equals to cluster.connect. Okay, and so we actually want to connect this to Cassandra again. So we'll go ahead and do from cassandra.cql engine. We're going to import connection. Okay, so here we go. So down here, we'll do connection.register connection, the string of the session, and then passing session equals to session, and then connection.set default connection, again, the string of the session, and the session equaling to the session. Okay, simple enough, or actually we don't need the session argument here, just the default. Okay, so again, this is very similar to what we did here, except I didn't actually implement these methods. I didn't import them directly. I just imported the connection altogether. So it feels like we might be done here, but not quite, right? So if we run it again, let's close this down with Control-C, let it close down fully, run it again. Oh, I got a syntax error here. Need a comma after config. Let's try that again. And so it's going to try to connect many, many times, which it is fine, but it's actually now connected a lot, too much, too many connections going on right now. And that's going to cause a problem in the long run. So what we want to do instead is connect it only one time, which I will do. But before I do that, let's actually set up a task for our models. So our models themselves are going to be the product model, which is models.product, and then the product scrape event model, which is models.product.scrape, or not dot, just simply scrape event. Okay. And then we also want to sync the tables. So from Cassandra, SQL Engine, and management, we're going to go ahead and import sync table. Okay. So let's sync the table for each one of these. So sync table of product and sync table of product scrape event. Okay, so we save that. Let's do a task here. And I want to just go ahead and print off let's go ahead and do the list products. Okay, so what this means is I'll just go ahead and create a list here of product.objects.all, and then we'll go ahead and do values list of just the ascends, and we'll go ahead and say flat equals to true. Okay, so we've got a new task here that we want to try out. Overall, this seems like it's ready to go. Let's go ahead and run our worker process again. I'm going to close this down because I actually made changes to the tasks. So whenever you do make changes, you need to refresh everything. Looks like I forgot a parentheses here. Let's make things a little easier on ourselves by actually placing things a little bit cleaner. Okay, there we go. Let's run that again. And again, it's connecting a bunch of times. And if we go into our notebooks, I'm going to go ahead and duplicate this Celery basics one. And this time I'm going to just call it Celery and Cassandra. Okay, so the task that I want to import is this list products task. And then we'll call the list products task itself. I don't think I need the arguments in there. It doesn't actually matter if I do. And then we'll delay it as well. And I'll delete these other ones. Edit and delete. I will actually restart this kernel and get rid of the arguments. We do not need those at all. Okay, so let's go ahead and restart our Celery and restart our kernel in here, assuming that I saved everything. So restart and clear output. There we go. And let's run this. So list products. I cannot actually list products this way. Okay. It's not allowing me with this connection, or at least this current connection. Now I'll explain why that is in a moment. Right here, we can actually delay it. And what do you know? It actually delays these tasks. Okay. So one of the downsides to how it currently is right here is it's certainly possible that we have a current connection, right? So what we want to do is just be on the safe side and say if there is a current connection, so if connection.cluster is not none, we're just going to go ahead and shut that down. So the connection, of course, is this CQL connection. And shut down. And then again, if the session is not none, we'll go ahead and shut that down too. So this will mean that I don't have, 15 sessions open. I just have probably one. Okay, so let's go ahead and restart this again. And come back in here, and I can run this again. I can run this as many times as I need. And it will actually run the session and print out those nodes, right? Let's run it again. And again. Looks like it's not getting that recent one. There we go. Cool. So it is now actually delaying these tasks. So your next question is, well, why didn't this one execute? Well, that's because this current actual Jupyter notebook does not have a session. So if we did from app import db, and now if I call session equals to db.get session, now I should be able to list things out. It's going to take a moment, but now it works. And that's because of how this get session works and the fact that Jupyter doesn't need it to initialize the same way that Celery does. And the other part of Celery itself is, if you think about it, the way Celery is going to work is not in the same process as Jupyter or FastAPI. So Jupyter itself just doesn't need to start it up, because inside of the database itself, that actual command of get session is starting it up, just like we did with the worker process. But the thing about Celery is, well, we totally could have our task started up, but that's probably not that efficient, especially to run this over and over and over again on every individual task. Now, if you're doing a ton of things, a huge workload, perhaps it will make sense to have it inside of the task. I just don't know when that ever would be. And this is also what the Cassandra documentation recommends as well. But at this point, we now have it fully aligned. It actually now can work completely inside of Celery and Cassandra. So what we need to do now is actually see how to do periodic tasks. That is, how do we actually schedule tasks to run, maybe like every 10 seconds? How do we do that? Now we're going to go ahead and set up periodic tasks. So inside of our Celery worker, we're going to define set up periodic tasks. It takes in a sender as argument and potentially other args and keyword args. Sender is the most important thing to us. And so it's really simple. We do sender.add periodic task, and then how often we want this thing to trigger. Let's say, for instance, every second. and then we actually call the task we want to use. Now, the easiest way to do this is have the tasks on worker.py. There are ways around that, but having them on worker.py means that I can just call it like random task like this, and then we can actually call it with a signature. We do .s, and I'll go ahead and say hello. We'll take a look at that signature thing in just a moment, but for now, this is the method, right? We just add the periodic task, and then we need to wrap it into our app with Celery app.on after configure and .connect. Okay, so after everything's configured, including setting up our Celery application, we now have this periodic tasks here. So let's go ahead and give this a shot. So every second now, it's going to run the random task function with the word hello in it. Okay, so now to do this, it's just like what we've seen before. So Celery app.worker.celery app. And we can actually call beat here. And if I hit enter, this will set up my beat worker. Now I could do it this way, right? And actually just go off of a different process for my beat, or I can use the worker itself and then do -- beat. This will do both of those things, the worker and the beat. So it's really up to you on how you want to go about doing this. I'm going to keep it on beat for a little bit and use this one. But what we should see is every second or so after it's configured, it should actually be printing out the weird thing that we said right here. It should actually show that up. But what we're not getting is the actual information for it. So just like with our worker, we want to go ahead and do our log level and info, hit enter, and now we should be able to actually see the printed statement for it. And there it is, right? So it's actually sending or scheduling it, sending it to actually run. But the thing is, this is just scheduling it. That's what the beat server does. It only schedules these things. It doesn't actually do the worker process. So in order for us to do the worker process, let me close down the Explorer here. I'm going to open up a new tab, or actually let's split the tab by going back up here, split it up, and we'll do source bin/activate. And then we're going to go ahead and do Celery --app app.worker.celery app and worker. And then again, the log level being info, hit enter. Now it's actually going to consume all of these tasks. It should have a number of them. Once it's all completely set up, it will go ahead and start running these tasks, right? It's going to have a lot that are backed up, which we could also verify by going into Redis itself. But here we go. So here are those tasks, and now they're actually executing. So there is certainly a difference between the beat process and the worker process. Now they can go together, right? So again, the command for them to go together is Celery app.worker.celery app, and then the worker itself, we've already seen that. And then if we do beat, there you go right there. And then we can also add that log level in here of info. And with our beat, we can also add in a location for our scheduler. So we can call it Celery beat-schedule. There are other ways to use schedulers. There's other backends to actually handle the scheduling for this. But I'm just going to keep it nice and simple. And what you'll see in your local application is that schedule will be right there, right? It's actually showing you that schedule, which is pretty cool. So it's actually going to pick up from what was already in there by default. And so this is actually a task that will run every second forever. Now, let's go ahead and cancel this out. I'm going to let the worker still run. Eventually, we'll put them together like with this command, but I'll let that worker still run. And what I want to do is I want to only run this task maybe for a certain duration. So I'm going to go ahead and say expires, and we'll do 10. Okay, so we're going to run this again, and I'm going to let this run. I'm going to clear this out with Command K, or we could always just reset it anyway. And so I'll come back to it in just a moment. But while I do, I want to show you what the signature thing does. So jumping into Celery Basics again, I'm going to just really simply look at this random task here, and we'll do it again. And I'll actually call .s on this. And if I hit enter, it's a slightly different result than what we've seen. This is just creating a signature for what needs to be called, right? So I can actually call it just like that. And so creating that signature is essentially letting the periodic task, the beat server, tell Celery, the actual worker, it's going to tell it, hey, you need to stop. You need to stop running this task right here. Okay. And so we might already still have a lot of tasks going, so I'm going to have to let that finish out before we can verify that it expires. But the general idea here is it now has this signature. So I can use this signature too, like this, and I can pass this all around, right? So if I ever needed to call it again, I would just call it like that, which is nice. So that's just a really cool little feature for those signatures, and that's how you want to make sure that you're using the scheduled tasks with those signatures. But of course, having expiration is nice. I'm going to go ahead and change this to just ABC just to see if that expiration is working. So eventually we'll see ABC over here instead of hello. But we also want to have another item here. Now, I mentioned earlier that perhaps you want to run every Monday morning, right? So what I'm going to do here is I'm going to import the schedule cron tab. So we're going to go ahead and right above the signals here, we're going to do from Celery.schedules, we're going to import cron tab. Okay. So if you're familiar with cron, it actually works a lot like that. But even if you're not familiar with it, I'm just going to give you a really simple example here. Okay. So we've got our periodic task here. Now what I want to do is the schedule up front. This is 1 second. So of course you could do any number of seconds here for it to run, right? Now what I want to do here is actually pass in the cron tab. So cron tab, and then we can do hour of, 8 minutes being 0. And then day of week is going to be, let's say it's every Tuesday. It's going to be the second day of the week. So there you go. That would actually run it every Tuesday at 8 a.m. Okay. Of course, you could do it at Monday. You can do it all sorts of places on that. And if we look in the documentation, do a search for cron tab, you'll see periodic tasks and cron tab schedules. And here is how it really explains all of the different things. There's a lot of references on how you can actually go about running this. And you can also go off of solar schedules. You can change the time zone. There's a lot of ways to do that. And there's just other ways to also configure how these things run, right? So you configure something like this, and it's actually very similar to this, but I think having it very explicit makes it a little bit easier to see what exactly is going on versus just making it a big dictionary of things that are going to run, and see how you can actually change the time zone in here as well. So if you need a default time zone to when these things are going to run, that's what you'll end up doing. So the actual periodic task that I'll probably end up doing will be something like this, where it is scrape products, and we'll actually run our scraping. So I'll just go ahead and print out doing scraping. We'll actually build this out over time, but for now, I'm just going to go ahead and implement the task for it. I'm going to comment these out and do sender.add periodic task. This again will be a cron tab. And in this case, I'm going to use minutes being equal to the */5. And then our task, of course, is scrape products and just .s, creating that signature. And so this should run our periodic task to scrape products every 5 minutes. Now it's going to actually be based off of these still to some degree. So I'm going to go ahead and use this in. And then I'll probably also implement a scrape product task, a single product. So I'll call this just simply scrape asyn. And this would pass in the asyn string or something along these lines. And then we would print out what that is. So print asyn. Okay, so inside of here then, what I would do instead is I'll go ahead and do scraping, and then for the asyn in queue, that actual list, then we would call scrape asyn and delay so that it is still a worker process and is delayed to another worker process with that asyn, just like that. And so we can actually run all sorts of creative things in here as well, like we've been seeing with our, apply async, right? So apply async. We can pass those sorts of things in here as well. We'll play around with that when we actually get the scraping function working. But for now, that's what I want to do. And so I'm also not going to have these as two separate processes. Instead, I would just have them as the one, which is why I actually made reference to it right here. And that way I can continuously run this scheduler and based off of every 5 minutes running a web scraping event. Now, this is actually just triggering the primary web scraping event, not actually individual ones. The individual ones, we might want them to run more frequently. But if this starts to balloon, like if we had 1,000 products in here and I ran this every 5 minutes, that means that it's going to delay another 1,000 events every 5 minutes, which may or may not be what you want to have happen. It's going to end up starting to be a lot of them and also potentially grounds for something like Amazon to block your IP address from even opening up their service. So we do have to be careful on that as far as actually scraping the pages and really how we handle certain requests. So for now, we're going to leave it at this and actually take a look at the later actual working process with the scraping in the future. Now we're going to go ahead and start the web scraping process using Selenium and Chrome driver. Now, some of you that are familiar with Python requests, you might be like, oh, can I just use this and then r.text? Generally speaking, yes. On Amazon, I have never been able to use Python requests to actually scrape Amazon.com. I have to use Selenium because it emulates an actual web page, a browser itself, which we'll see in a moment. So that's what we're going to do, is use Selenium and Chrome driver. Now, of course, if it's not installing on your system, if you're having issues with it, by all means, for the scraping portion, use Google Colab, DeepNote, or really any kind of cloud service that's using notebooks. So once you do get the scraping portion done, you can use our endpoint from our FastAPI along with ngrok to ingest that data. That was actually why I wanted to show you ngrok and ingesting third-party data from anywhere. So with that in mind, let's go ahead and start setting up our Selenium and Chrome driver data here. So first and foremost, I'm going to create a scraper client. So inside of our app, we're going to go ahead and do scraper.py, and I'm going to define a class called scraper. This class is going to have a method in here just called get and driver. This is where we're going to return our Selenium web driver. So there's two imports for this, and that is from Selenium. We're going to import the web driver. So of course, we could actually just do something like that, or rather webdriver.chrome. We could totally do something like that. Well, the problem with this is it'll actually open up a browser window every single time. So what we want to do instead is say driver is equal to this, of course. So we still will send this back, but we also want to add in a few options here, specifically for Chrome. So from selenium.webdriver.chrome.options, I'm going to import options. Okay, so now we want to actually declare several options for this Chrome driver. So first off, we'll initialize the options class and we'll pass it in to our driver here. So one of the options is to add the argument of simply headless. That means it won't actually open up a web browser for us, an additional web browser if we had one open or not. The other one is no sandbox. There is a mode that allows you to test things and just say no sandbox removes that. Okay, cool. So that's getting our basic driver for Chrome. Okay, I'm going to go ahead and keep it in as an instance here and actually come in and say driver is equal to none. And we'll say if self.driver is none, is none, then we will initialize all this stuff. Okay. And if it's, then we'll go ahead and set it like that. And then we'll just return self.driver. Okay. So this also might want an actual class option here. So I'm going to go ahead and copy and paste something here just to show that this is of type WebDriver, the WebDriver class. Cool. So, typing is a good idea. Now, how do we actually go ahead and do this? Well, there's one more aspect I want to add in, and that's from fake user agent. We're going to import the user agent. And so I'm going to go ahead and define a method called get user agent. And this is going to return a user agent instance. We're going to go ahead and just say verify SSL being false, and then I'll do .random. So the nice thing about doing a random user agent means that when I go to a web page, any web page, it's going to see it as something different each time, whether it's Chrome or Safari or Firefox or mobile. It's going to be jumping around to all of those different things. So we're going to go ahead and add that argument in now too as user-agent, and we'll set this equal to user agent. Right, and so let's go ahead and define that up here as get user agent. Simple enough. So let's go ahead and make sure that fake user agent is in our requirements. Might not be. It is not. So fake-user agent. And then we'll go ahead and do pip install-r requirements.txt just to make sure everything is installed. Cool. So now we have our basic scraper client. So let's actually go ahead and implement this in our notebooks. So jumping up into our notebooks, we're going to go ahead and create a new one. And we'll go ahead and scrape with Selenium basics. Let's just do it that way. And so naturally, we're going to go ahead and want to cd into our project root, which if you remember back, we did pwd, and then we just copy this, cd there. Okay, so now from app.scraper, or let's go ahead and do from app import scraper. Hey, it looks like we missed an R somewhere right there. Okay, and restart and run all. There we go. And here we go. So our scraper itself is going to be, let's call it our driver is scraper.scraper.get driver. Okay, so that will do everything necessary for our Chrome driver, which we can see just like that. So the other thing is, if I wanted to get rid of this headless option here and then run this, so kernel restart and run all, what it's going to do is actually open up that web browser, right? If you're on a Mac and it's asking for permissions to open this up, to actually run Chrome driver, what you're going to need to do is go into your settings and allow those permissions. So system preferences, and you'll see something like security and privacy. You would jump in here and you would see something to allow an app to open. Windows users, I don't think you'll need to do that, but it's certainly possible that you will in order to run the actual Chrome driver, right? To actually run Chrome driver on your system, which is really just opening up Chrome for us. Okay, so now let's go ahead and open up this web page here. And I'll go ahead and say driver.get, or let's declare the URL first actually. So URL equals to that. And then driver.get that URL, right? So let's go ahead and leave that up like that. And so this should get it. Now, in my case, I actually closed out the browser, so I need to refresh everything and bring back headless. And if you left the browser up, you would have seen it change pages. Okay, so now once the driver does get this URL, then we should be able to do driver.page source and hit enter. And that's really all we need to worry about. We are not going to be using Selenium to extract the data. We can use Selenium, but I think there's a better option for us. And realistically, if we were running scraping events, we don't have to extract the data yet. I could have saved, and I can save this entire page source. You can use some sort of block storage. Let's say, for instance, like AWS S3, DigitalOcean, Spaces, Linode, Object Storage, GCP, block storage, or GCP storage, I think it is. And so there's a lot of ways on how you could solve this. You could save this actually as a file and parse and scrape later. That is certainly a method that you might consider, considering the fact that the art and science of scraping is, well, sometimes more art than it is science. But I'm not going to do that. That's just an option if you really want to be good at getting this scraping down. Come to think of it, that would also allow us to start maybe building a actual machine learning algorithm to improve our scraping features as well. which is definitely outside the context of what we're doing here, but let me know if you want to see something like that. Anyway, so now we have this page source, right? So I just want to show you real fast that if I try to do the same thing with Python requests, it's going to feel like you should be able to do it, right? So Python requests would be r equals to requests.get, that same URL, and then r.text to get the HTML data. And we get this right here. To discuss automated access to Amazon data, hit us up for our API. Cool. So the API is probably something well worth looking into, but it's not something we're going to do at this point. We're going to be continuing to learn about this. So this is meant to be educational. We're going to learn about it and actually scrape this data and then parse it. But that means that I'm actually going to start building out my scraper a bit more. Now, I absolutely could separate this out from the scraper class, but this entire project is about doing this one thing. So this one class right here, we're going to build on top of it and kind of make this what we will use to actually perform the web scraping. And we'll just use our Jupyter notebooks to test out the things that we need to test. Now we're going to go ahead and execute JavaScript so we can have an endless scroll on any given web page. So what that means is we're going to update our scraper class here. And I'll go ahead and do from data classes. We're going to import the data class decorator. So it's a little bit easier to instantiate a scraper class. First off, we want the URL. This is going to be required. Next, we want to say if the endless scroll is available. So endless scroll. And this is going to be of type Boolean. And we'll set it the default to being false. And then we also probably want an endless scroll, maybe time. And we'll go ahead and put that as an integer, set it equal to 5. Okay. So with that, we're actually going to now implement a method just called get. And take in self. It's going to grab that URL and also a driver. So we'll go ahead and do driver equals to self.get driver. And then driver.get self.url. And then we want to say if self.endless scroll, then we're going to go ahead and perform endless scroll. So what you can do in the driver is you can do something like driver.execute script, right? So this script tag is very similar to jumping into your web browser, going to view, developer, view source, and implementing things like this, right? So if we press up a little bit, in my case, you can see I can alert things. I can also go to the scroll height of the document. Notice that these two numbers are different. I can also scroll to the scroll height of the document. So document.body.scroll height. And this is executing JavaScript. This is not that big of a deal, especially if you know JavaScript really well. But we can do it inside of here, inside of this driver. This allows for us to do something like this. Say current height is equal to driver.execute script, and we want to return document.body.scroll height. Right? That seems simple enough. Now we're going to run a loop, a while loop. So while true, we're going to go ahead and do driver.execute script. Let's go ahead and open this up a little bit. The script itself is going to be window.scroll to 0. That's the x-axis. And then the scroll height here. Okay. This is the starting scroll height, of course, or the current scroll height. And so then I want to do time.sleep. Let it actually scroll to this endless scroll time. So self.scroll time. Then we're going to go ahead and execute this again as our new height, or iter height, like the iteration height. And then if the new height or the iteration height is equal to the current height, then we're going to go ahead and break this loop, which probably means that it's done. Otherwise, we're going to set our current height equal to this iteration height. And that's it. And in this case, I'm going to return driver.page source. That's also it. Okay, cool. So let's give this a shot and go back into our Jupyter notebook here. We're going to go ahead and kernel, restart and clear output. And I'll go ahead and say s equals to scraper.scraper, just like that. Our URL is going to have to be this URL. And then our option for endless scroll will have to be true. Okay, so now that we've got that, let's go ahead, make sure everything's imported and ran. We can now run s.get, and it should actually do the endless scroll for us. So I'm going to get rid of these cells here. Run that. And it will take some time because it will definitely go through these iterations, right? And it will sleep in those iterations. In fact, I made a mistake. This should say import time. And so it probably even says that somewhere in here. Oh, we missed a parenthesis somewhere in here. Let's scroll down and make sure, the window scroll to needs a parenthesis right there. Okay, let's try it again. Kernel, restart and run all. It didn't even get to time.sleep. Okay, so now it's going to take some time to sleep and it's going to scroll to the very bottom. Now, by all means, you can test this by commenting out headless. This argument would absolutely open up the browser for you and you can see it scrolling down and all that. And at the end of the day, we will get this string back. Now, that is one of the reasons to use the actual scrolling or the endless scroll, right? And so I'm actually going to go ahead and define this as perform scroll. And now put this in here just like this. Self.perform scroll. Okay. That's a simple way to just, separate it out a little bit. Now I could also have it as a Boolean value in here, and perhaps that would be something I would want to do, but I'll leave it in like that, as in a Boolean value for if we want to perform this scroll or not. Maybe call it perform endless scroll. That might be a little better. Okay, so let's kernel, restart, and run all again, and it should work again. Okay, so the endless scroll, this is definitely not the only way to do it. One of the other ways is to just have a range of loops that you run through, give it some time to wait. Once it's actually finished, you can continuously just run this over and over and over again until some time out happens or some range. I just thought this was a clever method that I saw on Stack Overflow. Then I'm like, hey, that's really cool. Let's go ahead and do that one. Okay. Oh yeah. So we've got driver is not defined. And this should be the self.get driver, all of this stuff. So I'm actually going to pass in the driver here. And in this case, if the driver is none, we're going to just go ahead and return. Big part of that is that we want to make sure that we're performing this in the scroll when there's absolutely a URL that has already been accessed. There's a lot of other tests we could do for that one as well. I just wanted to make things as simple as possible for us. Okay, cool. So now it's actually time to parse out this data. Now we need to parse our actual HTML string, all this. And we're going to be using requests-html to do this. Now, it's not the only way to parse this data. You could use Beautiful Soup, and heck, you could even use the Selenium WebDriver. But I found request.html to be one of the easiest ways to do it, as we'll see in a moment. So let's go into our notebooks here, and I'm actually going to duplicate this original notebook. And now we're going to go ahead and scrape with Selenium and parse with requests.html. Okay, cool. So let's go ahead and hop in here. And what we want to do is we want to import request.html. So I'm going to leave pretty much everything the same here, but then change this to just being an HTML string. Okay, so let's go ahead and run everything, get it all looped up in there. And then we'll go ahead and do from requests_HTML. We're going to import the HTML class. I'm going to get rid of that other requests here. And now I want to go ahead and say HTML obj equals to HTML. And what we want to do is we want to pass in that HTML string here. A lot of HTML being said right now. Okay, so this should actually give us all of that HTML in there. Let's make sure we import everything. Okay, and so what I can do, this is why I like request HTML. I could just do find and table. So what this is going to do is find all of the table elements, the HTML table elements inside of that string that I passed. We can also do this for finding like anchor tags, and we can find href and do all sorts of cool stuff with that as well. So this is why I really like this. Another reason is if we go in here and maybe grab the price tag here. So if I go in here and go to inspect and look a little bit deeper, I see that there's this ID of price and our price, right? So this ID tag here, if you are familiar with CSS at all, or even JavaScript or jQuery, there's a lot of things that you might be familiar with. You can use the hashtag here and then the ID. And with that, I can actually find that specific item. And I can also say first being true, and then I can say text. That I think is just like so cool. But remember how I said there's an art and a science to all of this? That is what we want to discuss now. So what I just did will work for the price probably, in the long run even. So if I also go to the title, I could probably use something very similar for the title in product title. Okay, so going back, let me close this one out by going back in here. This is going to be our price. Let's say price string, and then title string is HTML object. Find that first, true, and text. Find will always return back a list of items here, unless we put first being true. Okay, so we've got our title string and our price. Cool. But remember back, let's look at our data that we are trying to get. All right, so back into our models, we want ASN, price string, and the title. So how do we get this ASN number? Okay, so again, we can be very artistic about it, uncreative, and scroll down, look for ASN, just do Command F, look for ASN. You'll see something like this, product information. This also gives a lot of other information about this product. So if we inspect in here, maybe, or actually let's go ahead and go into where the ASN is. Let's inspect in there. Maybe there's an ID in here. I actually don't see an ID. I see product det attribute value. Okay, that is a class value. There's two classes in here, of course. So we could probably use both of these, but I'm going to go ahead and go off of this one. This one seems like it's about this particular item. And so I'm going to go ahead and assume the ASN is the obj object.find. That there, we'll go ahead and say first being true, and then we'll do text. And then, hey, let's look at the ASN. Wait a minute, that's not the ASN. Of course it's not, right? It's this. Now, I already knew this because I've, tested this out. I wanted to practice here. And so this is where the art comes in. It's like, how do we actually find that value? Now, if you know HTML well, you will recognize, hey, that is a table. This is the table body. This is a table row. Each row has two columns. One column is describing the value, or it's the key. The other one is the value of that key. And if we keep going down this item, we see that all across the board. Now all of this information might be information I want to keep, right? So how do we go about doing that? Well, let's get rid of this for now and say tables equals to HTML object dot find table. So this is just finding all of the tables inside of this entire page, right? So every single one of these table objects here. So we can print this out. And what do you know? There's a bunch of table objects in here. Now, I may or may not know what's inside of these elements. And actually, that doesn't matter to me. Let's go ahead and iterate through them. So for table in tables, we're going to go ahead and print out what the table is. Okay, no big deal here. Now, I can also do table.text and see what that is. This isn't really that useful to me. It's kind of jumbled up. And sure, it could probably make Python regular expression to extract all this data and do some crazy stuff, but that's not intuitive. Instead, what I want to do is I want to iterate through each row that's in here. So the first thing I need to do is check what the children are. So table.element get children. Now, thinking in terms of HTML itself, children are anything that's directly inside of this. It's not everything below it. It's just this T body right here. It's not all the rows in there. That's the child of T body. The only child of table, or this particular table, is T body. And we should be able to see that by this command right here. And that shows me a bunch of elements that are T body, right? Some tables have no children, which means I don't care about them. So now I can go ahead and say for T body in this right here. Now, some web pages might have other things in there. Maybe it's not properly formatted, but in the case of Amazon, it is. So now again, I can print out what T body is, and there's a bunch of T body. Now, what you might want to try is say something like for, row in, or let's call it the table row tr in tbody.element.get children, and then print out the table row. Okay, run that again. And now it's saying HTML element has no attribute element. Okay, so if we actually did this, and let's take a look at the tbody again and said, print out the type of tbody versus the type of table. Oops, let's go ahead and print both of these. It will stop after one iteration. But we see this first one is a element. The second one is an HTML element, which means I probably don't need to type out .element. That's it. This comes with time and intuition and using this stuff. So now, if I print this out, I've got a bunch of table rows here. Okay, so inside of there, we're going to go ahead and do for column in. Well, it makes sense to me that it would be the same as this. So tr. Okay, let's go ahead and print out what the column is. And we'll keep the table row for a moment. But now we should be seeing TDs in here as well, as in table column and also a table header. So that's pretty cool. So what if I did the text for the column? Okay, so if I print out text, I'm getting a lot of stuff in here, but I'm also getting a lot of nones. So there is another way to get from an element, and that is doing text content. And what that does is kind of give us a little bit better of a look, but it should have pretty much all this data. So what I'm going to do here is I'm going to go ahead and say the row is equal to an empty list here. And I'm just going to append to this empty list column.text content with the parentheses, right? I knew of this method. Of course, if you want to learn of the various methods, you can print out what's in the dir, and that would be a way to sort of reverse engineer that yourself. Anyways, okay, so now we've got this. And now I'm going to go ahead and print out that row itself. And we'll run this again. And so now we are seeing a little bit better of content overall. It's still not great, right? It's still not necessarily in the best spot. But if we scroll down a bit, I think we can actually search for ASN. And here is the data that I'm really looking for here, right? So this is the content. Here is a key, here's a value. Here's a key value pair, key value. Okay, so I basically want to try and turn every column into that key value pair. So basically, in other words, I want to say that if the length of the row is equal to 2, then I probably have a key value pair. That actually changes my data a lot. Now, again, this may or may not be true. It's not always going to be true, right? Sometimes it will be, sometimes it will not be. So instead of actually doing it is equal to 2, I'm just going to go ahead and say if it's not equal to 2, then I'm going to go ahead and hit continue. Otherwise, now that I've got this, I can kind of make an assumption about the rows themselves, get the first value and get the second value, and then print out the key value pair. Okay, it's kind of hard to tell this right here. So let's go ahead and actually add in a dictionary here. So this is going to be my row values. And we'll go ahead and do data equals to empty, and then data value, or rather data key is equal to value, and values.append data. Actually, let's call this data set instead. And we'll print this out. In fact, the data set itself could probably be outside of the rows too. It doesn't really need to be in there right there. So there we go. So we print out a data set here, and it's starting to look a little bit better. It's kind of hard to tell based off of how it currently is because I printed out all of that data. Let's try that again. Cool. So it's definitely getting closer. So the content, though, is definitely a challenge. This is not great content. We need to strip out a lot of the Python-ness of it. So what I want to do then is give an empty string for this content, and I want to try to grab that content again. So this time it's going to be content equals to this, and then we'll do accept pass. So yet again, I will absolutely be appending this content. Well, really, if it's not equal to an empty string, right? So that means that I can actually extract the content right here. So let's go ahead and do that. And now I'll go ahead and append it. But I can also actually clean this up. So I'll go ahead and use underscore content to just signify that I'm cleaning it. And it's going to be whatever this content is .strip. So that's what I'll append now. And then we can replace items in here as well. But now hopefully I'll see a little bit better of content. So now if I see that, it is showing this a little bit better. Cool. So there is another package that I actually ended up installing. So if we go into requirements.txt, we've got this Python slugify package. Now the reason for that was for my key. So we're going to come back to the top here and do from slugify import slugify. Scroll down a bit. And now my key value, I'll say key equals to the slugify of the original key. And so the key value is now a slug value, which would be a lot better for a couple things. For an actual key in a Python dictionary, but also when we try to send this data to our backend. Okay. Slugify needs to be defined. So let's run that. Run this again. And cool. So now we have this data. So my assumption actually is now this data itself, the actual key, will probably not be replaced. So let's actually change this data set from a list to being a dictionary itself. And now what I want to do is I want to check if key in the data set, then I'll just go ahead and say continue. Otherwise, we're going to go ahead and say data set key is equal to that value. No longer appending it, but now making one big dictionary. Let's actually pretty print this. I'm going to import pprint, and we'll do pprint.pprint. I thought I ran that. I did not. Let's run that cell. And what do you know? It's much easier to see. We have an ASN there. We've got a brand. We've got a color. We've got a country of origin. We have some stuff about a customer reviews. We have got a lot of cool stuff in here. List price. It's showing a list price, which is nice, but we already did actually find a price. So we could probably use this price to, verify the other price that we found, which maybe isn't the same. In this case, it's not. And we might find other prices. Look at, there's another price, right? So we have all sorts of things going on here. This other price, of course, has a lot of data we just simply don't need, which there is a way to clean that up, and we will. But the idea here is we have all of this data now that we've been wanting to actually extract. But more critically, the most critical piece is the ASN here, as well as the actual product title and our price. Like quite literally copying what we've got in our data model here in both places, right? So that is the bare minimum of what we would need to track. So now it's actually time to implement this inside of our actual scraper itself. Now this is a really good reason as to why you'd want to use Jupyter. I had to jump back and forth and find things that I'm really interested in. I will say that I know for sure this tables method does not work on every product on Amazon.com. It certainly works on like electronic items and like physical goods. A lot of the digital goods don't necessarily have this same structure. But notice that the table itself, it's not about the classes, it's not about the IDs. It's just a table. It's just an HTML table. And then it's looking for things that have key value pairs, which are really just kind of two rows like this, right? Or two columns rather, with a bunch of different rows as the titles and then a bunch of different columns as the values. So one other thing that we could think about is actually, instead of looking for just tables, but looking for the TH, like the table header and the table column, that would be another way to do it, right? I'm not going to do that, but I will say that implementing something like this is, I think, a preferred method to these. So like product title and our price block, our price, these two are really vulnerable, right? They're vulnerable in the sense that, what if Amazon just decides that they want to call this product dash title? Now I'm kind of in a spot where maybe my scraper is broken and I don't necessarily know about it for a while. Whereas this table here, this is not broken. This is going to work going forward. Granted, the data itself can be cleaned up. And also, especially for like the price data, there's probably a way to extract the actual price itself versus trying to clean everything else in there. So I really like this method of actually just finding a table and iterating through it to extract the data we want. Now, when it comes to all of this other data, this is definitely something that you could also consider trying to scrape, like maybe the customer reviews, right? Maybe you want to track what the customer reviews are over time. Now, that adds another layer of complexity that we're not going to cover, but you could essentially use the same methodology here for these reviews because there is going to be some sort of structure to them. Will it be the same structure as the tables? Probably not, right? So if we look in here, it already doesn't look like it's a table. It looks like it's all sorts of other things, right? And so this is the art and science of actually starting to scrape data and parsing it. Parsing it is the science, probably not so much the scraping part of it. So now we're going to go ahead and prepare this for our scrape client. In other words, I want to be able to add a method right on my scraper to handle all of this stuff. So the first thing is to define extract dataset. And all I want to do here is get everything that's going on with this. So I'm going to go ahead and cut this out here, including the dataset, and paste this in here. Okay, so we want to actually put in the tables. So we're going to actually run the tables in here. And so this is going to return our data set. And now we're going to extract data set on these tables. Okay, so we need to make sure that our tables are defined. I might need to rerun everything. Let me just do that real fast. And then, of course, we will, at the last of it, we'll go ahead and call this our data set equaling to that. And then we'll pretty print it, assuming everything's run correctly. Okay, so we'll give that a moment to scrape. There's our data set, and it prints it out. Okay, great. So now I have the ability to do that, which also means that I want something like define extract tables. And in this case, I'm going to go ahead and pass in that HTML object, and it's going to be simple. Just going to find those tables. And we'll go ahead and leave self out for a moment. And I'll push this up one. And then we'll just call this extract tables. And then these two things are essentially the same. So what I want to do here is we'll just say define extract element and value, or element text. That's probably the best. So the element ID, this time it's going to go ahead and look for the element. So L equals to something like this, right? And so this is going to have to be the element ID. Then we'll go ahead and say if not element, then we'll return an empty string Otherwise, we'll return element.text. Okay, so I'm going to push this down a little bit, or rather keep it up. And then in here, we'll just call this. I should actually push in the HTML object as well. There we go. And so that should be simple enough. There's a way to do the price string. And then the same exact thing for this part. Cool. Okay, so now we have several methods that we can implement on our client. But there is one more thing that I want to do, and that's inside of my data sets, right? So inside of the data sets, if we take a look, oops, we left out the HTML object here. So inside of the data set, I have the ability to, well, first of all, I see the key, and then I have a value. So in here, I can actually update this a little bit more. And so in the data set itself, what I want to do is I want to see if a $sign is in the value. And then if it is, then I'm going to go ahead and say my new key is equal to, well, the original key. My old key is equal to the string of key and raw. Okay, and my new value, well, I'll go ahead and keep it as value, and then old value is also the, it's going to be a new value in just a moment. So the idea here is to iterate through this and check if these values are there, and then update our data set accordingly. Okay, so I'm actually going to put this down here, tab this over, and say else. Right? So if the $sign is in that new value, then we're going to go ahead and say data set and new key is equal to our new value, and data set old key is equal to our old value. So the idea is our new value, we need to actually extract some data here. So that extraction is going to be a regular expression, and I'm just going to give it to you, because explaining how this regular expression works is probably not worth it. In this case, this will extract a dollar amount. So $sign something, it will look for that dollar amount and be able to extract it. And the only reason I can do this is because there is a $sign in there. Granted, it doesn't work for all forms of currency, just a US dollar. So let's go ahead and import a regular expression now. Okay, and then come down here, run the data set again, or actually call it on this new key. Just passing in that value. We extract it again. And this time, oh, I didn't actually set it up. So let's run that. And now what we should see, we've got a list price. There it is. List price raw. Still has all that other stuff in there if I ever wanted to clean it in the future. And there's our price. So we have a new price that's showing up that is similar to our price string, potentially the same, potentially not. So the price string is going to be just slightly different. But now that I have all this different data and all these different methods, it's time to actually bring it over to our client. Okay, so first and foremost, we're going to go ahead and bring over this extract element text item. And we'll come in here into our scraper. And I'm going to go ahead and just put it right here. Okay, so we've got this HTML object that we're going to have to pass in here, which, we don't actually perform anywhere. We don't put anywhere. So let's go ahead and define get HTML object. And the goal here is to convert whatever this get call is and turn it into the HTML object that we have here, right? So we've got that HTML string and then that HTML object. Okay, so let's go ahead and bring all of these imports in here with the exception of the pretty print function. We don't need that. Go all the way to the top. There it is. Okay, so now in here, we're going to go ahead and say HTML string equals to self.get. And then the HTML object is this right here. And then we're going to return that HTML object. Okay. So the thing about this is I can actually also set this as a value on my scraper class. So HTML object is going to be equal to the HTML class, and we'll set it as none. And so really, if self.html object is none, then we're going to go ahead and grab it and set it right there, and then return it. Okay, so really I want to come down here and call scrape. Okay, or perform, but I'll leave it in a scrape. And in this case, well, what is it that I'm trying to scrape? Well, it's all of these different elements here. So it's this price string. So let's go ahead and bring this one in. And we've got, oh, we already have it in there. And so in here, this should be our HTML object equals to self.getHTML object. Okay, which also means that I probably want to run this first in my scraping method here. All right, which also means that, perhaps I can combine these two. I'm not going to do that right now because I want to leave this API intact, but we're going to do that scrape HTML object. Next is getting each element in there. The first one being our price string here. But this time I actually do not need to include the HTML object in the request or the actual method call. I would just do self dot and get this. Okay. And same thing is true for the title. So go ahead and do title and get that title element ID there. Okay. So the next thing is extracting our tables. So again, we're going to go ahead and come in here. And this time it's a little bit more simple. And just passing in self. So again, I'll go ahead and do tables equals to self.extract tables. And then finally, we should have this string here. This is actually a valuable utility method, so I'm going to actually keep it out of the class itself. Probably use it somewhere else. Make sure the regular expressions are imported as well. Okay, and then the dataset method here. Extract tables. Or I think we should call this extract dataset if it's not already. That it is. This time we'll do self and tables. Maybe extract table dataset. Because if we ever find a list dataset, then perhaps we'll do that one. So the dataset equals to self.extract table dataset. And then we're going to return some sort of dictionary. So we'll go ahead and do the price string here. We'll go ahead and do the title string here. And then we'll unpack the data set itself, which should be a dictionary. Okay, so we should see a dictionary coming back, and we can add some type hints in here for that to return a dictionary. Okay, so let's give this a shot now. I'm going to duplicate this original one, and I'm going to rename it to simply just scrape client. Then we'll jump into our scrape client here. Okay, so we have this get here. Now we should just be able to do data set equals to all of that and just simply scrape. At least hopefully that simply. And I'll delete all of these other things. I no longer need them. Let's give this a shot. So there is a possibility that I need to update something related to the endless scroll. And that is, the nice thing about the endless scroll is it will take some time prior to actually extracting the HTML itself. So let me just scroll up to that in the code. So in this endless scroll, if I call it every time, it's going to continuously scroll and it's eventually going to run on this time. So it's for sure almost going to run for 5 seconds before we ever actually get the data. So inside of get here, it runs for 5 seconds, right? And the idea for me is I want to go ahead and say if the endless scroll is false, then I want to do time.sleep. So if self.endless scroll, then we'll do that. Otherwise, we'll do time.sleep and some arbitrary number. I'm just going to leave it in as 10 seconds. That way, for sure, it's going to wait for the entire page to load, and then it's going to go ahead and return back the data page source there. Okay. Oh, and we missed a required argument on our tables or on our data set itself by putting the tables there. Okay. Let's go ahead and try that again. So kernel, restart and run all. All right. So here's our data set. There we go. So one of the key things about doing web scraping is to not overload anyone else's service, right? So I really wanted to have these sleep times as well as the endless scroll, mainly so that I'm not overloading Amazon.com. Now, it's kind of an oxymoron to say that I would overload Amazon.com, but the idea is if you are starting to do unnatural scraping, Amazon or any service will probably stop you from doing that. They'll start to block the requests that you're giving because you're not doing it in a way that's like a good web scraping citizen. So that in that way, we want to just have a sleep timer of 10 seconds. That's actually not that much time, especially if we're going to just be continuously doing this. Like every minute or so, we're going to do another request for this exact same product. That's kind of the idea here. Okay, cool. So now what we want to do is just do this one more time, but this time actually going based off of an actual asyn. So I'm going to go ahead and copy this. Again, we'll duplicate it, and I'm going to come in here and rename it. And this time we're going to call it scrape client via asyn. Okay. So the asyn itself is always in the URL for the product detail view. And this is it right here. We can verify that by scrolling down, right? So there it is. And a quick way to get to any URL is to grab Amazon.com and then the DP and then the asyn. Now, this same URL setup is not the same everywhere in the world. Every version of Amazon doesn't necessarily look like this. I've seen Great Britain as well. I think it's GB. But in the US, this is what it looks like. And so the asyn itself, I'll go ahead and grab this here. I'm going to comment out this URL, save it, and we'll give it a shot. And yet again, I mean, it'll take probably 15 seconds or so, maybe a little bit longer to fully scrape this. But this time it should be based off of the asyn, and it should go to the exact same data. Now, granted, we could also print out that URL to see what it is and actually go to it, right? So if we actually went to this URL, we could verify that it is the same product just looking at it, right? And it is. I know for sure it is. But anyway, so that's pretty cool. We now have the foundation for our scraping client to be able to run as a periodic task and also to store it, right? So we want to do both of those things in the next one. Now we're going to go ahead and put it all together. So if you remember back to our worker, we actually had a query set that gave me all of this stored asyns I have in my Cassandra database. From there, it actually called an individual scrape element, and we could almost use our scraper class, but we're missing something, and that is the asyn being a constructor. So I'm going to go ahead and set the asyn to none as well as the URL to none. And in here, I'm now going to define a post init method here, and that's 2 underscores, post underscore init underscore underscore self, and then we're going to go ahead and say if self.asyn. Then we're going to go ahead and say self.url equals to the f string of https://www.amazon.com/dp and then self.asyn with the trailing slash. And then if not self.asyn or self.url or not self.url, then we want to raise an exception and say just say asyn or URL is required. Simple enough. Let's go ahead and just do a quick test on this one. Go back into our scrape client here. And this time, instead of instantiating it with a URL, we'll do it with a asyn. We'll restart and run all, assuming that I actually saved it. Worst case scenario, we can also print out what the actual URL is for the scraper. It is taking some time, so I think it's actually working. But there we go. That's actually what we'll want to do, because now inside of my worker, I should be able to actually scrape this. So let's go ahead and bring it in. So scraper, like that. We're going to scroll down a bit. And we've got our scrape asyn here. Right, so this is going to be s equals to scraper.scrape, asyn equals to asyn. All right. And then the endless scroll, we'll go ahead and just say true. This, of course, will allow us to grab our data set, just like that. Now, we just need to validate said data set. So grabbing the schema element. Now, in our case, we want to grab the schema element for, well, probably what the view would be. So going back into main, we want the same one as here, just to add some consistency. And then also the CRUD event as well. So in here, we'll go ahead and come into our worker again and bring in our schema. Okay, come down. And product list schema. So the product list schema is equal to schema, product list schema. We can actually just say clean data or validated data is equal to that. That data set, of course, is a dictionary. There we go. So we've got our validated data here. And then from there, much like we did in main, we can just send it on down. Send it on down. Okay. Don't you worry, we will absolutely implement this elsewhere as well. Okay, so now we should have everything working. Assuming that I imported CRUD, which I did not. Now, if you were like me, you would have had your worker running that whole time. So my worker was running, and it is attempting to emulate a lot of these things. So I'm going to go ahead and close this down, let it close naturally as that on its own, and then I'm going to go ahead and run this. Now, one of the things about this is some of these asyns are incorrect. So it's going to be a page not found, right? So perhaps it'd be better if I actually deleted all of my product objects first and then actually found some real ones to start with, right? And to really improve everything, I would actually have another item in my scraper to find new asyns on the page. That is just adding some complexity to this, and we don't necessarily need it. And looks like we have an import error. Scrape is supposed to be scraper. Okay. No big deal there. So before I actually run that again, let's actually implement this and jump into our notebook here. I'm going to duplicate this. This time it's going to be rename scrape via worker task. There it is. And so now from app import worker, and our worker task is just simply scrape asyn. So worker.scrape asyn. There we go. Initially, we'll leave it like that, and then we will have it going with Celery. So first step, see if it even works. Outside of Celery, see if it even works. Something I didn't do that I probably should is actually initialize the database as well, the database session. I think I probably got that error already. So session equals to db.get session. And yep, we got an engine exception here. Couldn't do it. Okay, so we created that session, and now I should be able to call the worker in the Jupyter notebook. And we should get a valid response, hopefully. We'll see. It appears that we have. Okay, so I didn't actually return anything. I suppose I could return the scrape event itself, or print out the product itself, so like we do in the view. I'm just going to go ahead and print out what that product is, and I won't return anything because this is going to be mostly scraped. And we'll go ahead and do ascend and that product. So the passed in ascend just like that. And I'll give it another shot. Restart and run all. And while that is running, I'll go ahead and start up my worker and my beat process again. Looks like we have, a silly error. Didn't put an equals. Okay, so there that goes. And restart and run all. And what's going to happen is, well, in some cases, it will not find a data set. Thus, it will not be validated, and so on. So we probably still need to improve this just a little bit. And in this case, it worked fine. But what we would probably see in our worker is if I came in here and said validated data, let's just put it into a try block and say except validated data is none. And then we'll just go ahead and say if validated data is not none, then we'll go through with actually adding it into our database. So let's go ahead and restart the actual Celery again, actual worker process. I'm just going to let that run. It's going to be running in the background, and the way we had it set up was it's going to run, every 5 minutes. So it's going to take a little bit before it actually executes. But that's why I have the scrape worker in the actual Jupyter notebook, is so I can restart and run all here. And if I actually do have a worker process that I wanted to test out, let's say, for instance, we grab this one and we come in here and just give some arbitrary one and do delay, this should work. And so should not delay. Both of these just won't actually scrape anything. First one will give a asynchronous result, and it should actually start scraping as soon as it gets it, right? Task received, and it was done. It returned nothing back. That's why it says none. So the actual method itself returns nothing, right? So in this case, it returned nothing, but in some cases, it will return something else, right? So I think that's pretty cool. We could also do the same thing here. Just delay it. It'll send it to the background, and it'll run it there. So I'll actually return the ascend here and maybe true. Here I'll return the ascend and false, like it failed. And then that way, when it does run, we'll see that. Okay, so this is now running. It's running correctly for ascends that even exist. And now I'm actually starting to get a big old data set. Thanks so much for watching. Hopefully you got a lot out of this one. And as you might imagine, if we continue down the path of scraping all this data and maybe doing thousands of products, we can start to see how our data set is going to balloon to be massive. And it's going to track all of those price changes, and then maybe you take action on that. Or not. You can also just see some trends or some historical patterns and really just get into the amazingness that could be with this big data. And of course, the Cassandra database service, Astra DB, is absolutely going to be there and be able to handle it all. And I think it's actually really easy to implement once you get past some of the early configuration hurdles that you might have faced. Even those weren't that big of a deal. But I do intend to cover a lot more about Cassandra and Astra DB, so let me know your comments and suggestions for future projects below. Be sure to subscribe and look forward to seeing you guys next time. Thanks again.